Hey, Jim.
Hey guys, can you hear me?
Yes. Work will be a little late today, Nilesh.
Okay. What's going on?
He's driving from Everett and stuck in traffic.
Oh, okay. Yeah, that traffic is, it's a growing problem.
Yes.
The number of people living in our area has, I think, by my gut tells me it's probably doubled in the last 10 years, just in this area. In the King County area, I would say, huge number of people coming in, and traffic jams in a small town of Sammamish is what I have seen, which just sounds crazy. Where we used to be 40,000 people, and now it's probably 100.
I believe that.
Yeah, lots of people. But the good thing, rather, the side effect is that property prices have more than doubled, like all over the place, all the way from south of Tacoma all the way through north in Everett and beyond. All this, the whole segment of people where people live, it is the prices have doubled, which is something similar to happened in Vancouver, in BC. The same thing I think is happening now here in our area, which is lots of factors like Chinese immigrants coming in. You have California people coming in. I don't call them immigrants, but.
So I heard that, I can't remember the name of the company, but it's a Chinese company that's going to be moving into Bellevue, building a research and development to compete with Amazon.
I know.
Isn't that crazy? Yeah.
And it is, I think you're talking about Alibaba, maybe not, but I don't.
It's something like that, yeah.
Alibaba is a B2B e-commerce, Chinese origin, and it's a good company. It is also probably one of the biggest in China, and that is, I heard, coming. Also, another thing happening in our area is University of Washington and another famous university in China teaming together to form an education center in Bellevue. That is also happening. I don't know what it means, but that is similar in nature.
Interesting.
Yeah. So all efforts are happening across the board. You can see them, which is, I think, overall it's a good sign of progress in at least our area. No doubt about that. No doubt. Okay, let's see if we can start discussions today with, I think, a bit of recap. We have covered a whole lot of ground, and we went quite a bit deep in a variety of sets, a variety of exercises. So I want to recap briefly, making sure that everybody is on the page of having solid understanding of what we have been doing up until now, why we are doing these things, what does it make, entail to from a corporate consumer perspective, or a company who is using cloud services. What does it mean to them? What does it mean to each and every one of us as to, we will be the people, we are the people that work, that build, that help accomplish a business solution for a company, for an enterprise, basically your employer. And so the thing that I want to briefly discuss is this book that I suspect you might have read already. The book I'm talking about is the Goal book. I'm assuming that you have read it. Assumption is sometimes incorrect, but I suspect you have told me that you have read the book. Now we'll briefly go into a quick recap of that book itself and see how it applies to us from a collaboration perspective, from a collaboratively producing some results. And that's what we really want to accomplish. So we have only 1, 2, 3, 4 people today. I think we should not wait. We'll record. We are recording. We should just go on. I don't have the idea of waiting for people to trickle in, because that disturbs everybody else. So I'm not stopping. I'm just understanding that people will come in. There are 4 people missing right now, like half of you, and yeah, we are just going ahead. Sorry. Okay, so this book Goal has certain key things to remember, and that's what I will not just completely go through the book itself, but just key aspects of the book that I think worth discussing is what I want to discuss today. So the book that I'm talking about is on this book summary that I have here in that location. And that's what I think I wanted to go through. This summary slide share will probably be a good one. So key things that I will remind myself and then describe those things is what I'm pulling up from here. Basically, is the key items. The key things to remember is what I will focus on, like in this summary sheet that you see in presentation format. A couple of things that you will immediately recall if you have read the book. But even if you have not, the scenario in which this person who is known as Alex Krogo, the idea of this person was to make the company that he's working on, make that company very efficient. Efficiency as high as 100%. Utilization as high as possibly humanly practically possible. Now these things do not necessarily mean they're accomplishing a goal. That's something that I find people find it counterintuitive. That if I have a big machine, I spend millions of dollars in that machine with equipment, isn't it true that I should make that machine highly efficient and utilize it to the best possible extent? Should I not do that? Is that what you're telling me? The answer is yes. That is exactly what I'm saying, is that this is itself not a goal in the business. To spend a machine, say $2 million on a big machine, and you have that here up and running, and your goal should not be just to make sure that you are utilizing this machine 100%. That is not a good idea. Utilization numbers alone do not mean anything. Alone. And I hope you know why, because you have read the book. But if you do not, I'll give you some examples as to where it doesn't make sense. So the idea that I will describe, where it actually gives you some sense of why utilization alone doesn't make sense in terms of accomplishing a goal, is simply the idea of inventory. Your inventory of things that you have in your company, that your company makes certain things. In most of our cases, we will have some kind of a dependency structure. Like, you will have team A, let's say team number A, team number B, team number C. 3 teams together make some things that are input to the other team, and these guys finally produce a product that goes to the customer. So this is the dependency map that we have in our mind. So the customer receives the output from this team. This team B produces the input for team C, and this team A produces input for team B. And these guys are getting components from the supplier. That's how you think about it. Now, if you have a very expensive machine sitting right here with this team, this team has like a $2 million machine in operation, and you want to make sure that they maximize its utilization. If you attempt to do that, what happens is the inventory piled up at this point will be huge. And the inventory here will be tiny, because you are now maximizing your production of this equipment in this team's control. And so what happens is this machine is expensive, it is efficient, it is producing a ton of interim product. Interim product is what you have an inventory sitting right here. And that is growing in its size, its quantum, because this machine is very efficient. It is run by team number B. And it is efficient, and it is creating a ton of content material that is huge, and depleting content that is here, because it is taking all the input and producing a ton of output. The problem with producing a ton of output is that this inventory that is stuck here is waste. Why is it waste? Do you know? Can you tell me why inventory is stuck here, like in the supply chain coming in and then giving it to A, and then A makes something and gives it to B, and B makes something and gives it to C, and then C makes something to give it to the customer?
Well,
Now,
all your inventory is taking up space and consuming money, and there's no demand for it.
Yes, exactly. So this interim component you have here is kind of wasteful in producing a ton of, because it is sitting idle. It does not generate money. it cannot be sold. You still have this team has to work on top of this unit to make a final product P that you can sell to this customer to get the dollar. Right? That's what you want to receive from the customer. And you cannot sell them this stuff. They need the product, which requires the work done by team C. So that dependency is in place. So just because you have equipment and with some team somewhere along the chain, along your supply chain towards your customer, you maximize its production, you make sure that everything is as efficient as possible, is not necessarily a good idea. That's one concept I want to make sure that you understand. What does this translate to in practice? In computer science, in our industry, since we are not actually dealing with stuff, it actually translates to what I call unfinished product, unfinished software, unfinished something, Git commits. You have done a bunch of work. You created branches and branches of useful features with a ton of people involved and creating an elaborate set of features that are essentially unfinished software. This unfinished business is, I think, the root of the problem of what I call lack of revenue or lack of profitability. That is the foundation of profitability. Yeah, lack of profitability. This is one of the root of the problems when you don't actually finish the stuff. You have a bunch of teams working in this and that and interim products, but the goal should not be just to make that team do grunt work and just keep on chugging along producing something that nobody knows why they're doing it. And that is something that is very, very important to think about, is you always think about what are we really selling to the customer and do just that, only that. And anything else that is a necessary input to what goes to the customer. And everything else, it can wait, absolutely wait. And it should wait because there is no reason to do it in the first place. Unless you know that there is going to be a customer that wants it or may want it, that's a different story. But if you know that this is going to sit idle and I'm going to make a new feature and I'm going to prepare it and work on it hard and have my whole team dedicated to doing just that one thing that doesn't actually reach the end customer in a manner that the customer wants to pay us money. And that is something which is generally considered waste. Even if you're doing it highly efficiently and you're producing it and all that, but that is not what we want in an organization. That's something I want you to really understand and put in practice. Let's see if I skipped another concept. Another concept was, I think this is the idea here, what I just mentioned is dependent events, and you have read the book. In the book it mentions that with some concepts about statistics and math involved in there, which I just briefly described. I did not go through detail. Now, another idea that I wanted to discuss is this idea of teamwork, which is, let's see that example. An example would be something like this. We will define our goal. Our goal is to have these people. We have A, B, C, D, E, and F. 6 primary school children. Let's call them primary school children. Primary. And so you are an adult. You are a responsible adult who is responsible and a good citizen. With that understood, the idea is you are going to be chaperoning these 6 primary school kids in a hike. The hike goes to the top of the mountain. And that's your goal, is to have the entire group and you from the ground level all the way to the top level in the fastest amount of time, the quickest, shortest time. What would you do? By the way, these kids have different capabilities, like this F is more like me, fat and slow, and A is very agile.
Slowest in front.
Sorry?
Slowest in front.
Slowest in front. Yes, yes, indeed. Do you know why? Why
Well,
slowest?
otherwise, you might leave them behind if nobody's watching them.
Correct. Yes, you have what is known as the gap between people. Let's say if this is the order of speed in which the fastest and the slowest. If this is the order, then I would like to put the sequence in a chain that goes like pretty much like this: A, B, C, D, E, and F, in that order, and put them in a row like this. And I am going to stand behind them, and then make them follow each other. If you don't do it that way, if say, for example, if you put A ahead in line here and let that person go ahead, he or she will run because he is agile and very fast. And so you will suddenly increase the gap. The gap between, let's draw it again. The gap between B, C, D, E, and F, and then A is here. And so now you are worried about the possibility of him getting, something wrong, something bad happening to him or her. And so that distance is conceptually similar to the idea of wasted inventory. You're increasing the distance between A and F, the physical distance, and so your anxiety level goes up because the inventory, which is theoretically similar to the distance between A and F, that is increasing. You don't know what A is doing, and he has or she has gone way far ahead, and so that raises your anxiety, your blood pressure, and so that you don't want that. So that's one scenario. You will line them up in the slowest first person ahead. What else can you do to really mathematically optimize the performance of all these guys, A, B, C, D, E, and F? All of them need to reach the top, and you also along with them. And so that is what we want to optimize. What else can you do apart from this sorting of the speed and relative performance? Put slowest in the first place.
Load. You can change the load of the slowest and give the load to some of the faster.
Yes, change load. We do this all the time in companies, right? What do? This is called reallocation of work in teams. So if you have a team of A, B, C, D, E, F, and you see that a particular person seemingly has a lot of work, you take some load balancing. Take load from A and one person and give it to another person. So imagine if you have again the same kind of people, A, B, C, D, E, F, and these people all the way through F. F is slow and also heavily loaded. So his backpack is heavy backpack. So what you want to do is like you're saying, take some load off this backpack and give it to this guy, or maybe this guy. So you spread the load and make it light for him or her. Another example that you could do in practice when there is no backpack, when you have a team working on some piece of software, some development work, something building together, which is not physical work, but more of our type of work, writing code or modifying something or getting things done, intellectual work in general. What can you do in that situation when you have the similar set of A through F, agile and fast versus slow?
Maybe add threads to the slower ones, so there's more than one working on the slower job.
Yes, meaning you want to hire another person, G, right? Or who is going to be even slower than F, or maybe another F prime who is equally slow. And so you have two slow people now working together on that particular task. And these guys, A, B, C, D, and E, they are doing their thing. They're individually doing their own thing. And you have F and F prime. Basically, you buy another person's services and have that person who is not slower necessarily, but another similar, equally slow and equally skilled in terms of skill level, who is also performing equally slow. Why do I say that we want to hire another slow person and not another A there? A couple of reasons. First of all, A may not have the skill to actually accomplish what F is doing. So may not have the skill, may not have skill. Another reason is that person may not be interested. And third reason is that person may be expensive. So that is something that you want to understand, that you cannot just randomly find the best person you can and put them right there and give them the job of what F is doing. This is, in simple example, let's go look at some what I call menial task. There is no such task as menial, but there are apparently some tasks that are menial, and it's by nature that they are. It's the tasks that are repetitive. They are kind of boring. And so people who are fast, are agile, are quick, and smart, and generally, decent people, they find that, they will not do these things. You know this. You don't do these boring things, right? If somebody tells you, hey, can you do this shipping and receiving task for me in the office? I don't think you will agree. Honestly, you won't do that, right? So that's the challenge. That you have to find the right kind. By the way, shipping and receiving is a critically important stuff that you actually have to do. That is how customers receive the product. If you don't ship, nothing will reach the customer. And that is actually the most critical part of the work chain. Actually shipping the item to the customer. Like this guy needs to, the end customer, where is that? I think I missed it. But the end customer, this customer needs to receive your package. And so this ship is the last step. That is typically boring, menial, and people don't want to do it. That is hard to understand. Smart people avoid doing that. And that is something that you have to be a part of the whole team, including the person who packages it up and ships it to the end customer. That is also a critical function. Without that thing, you don't get paid. No money. That is a problem that you have to understand. So if you attempt to hire for a program, I want to write, say, hello world. I want to write hello world. This hello world program in any language, you can see that, right? Simple program, you want to write hello world. Would you hire this guy to write that program? He's the best. At least according to me, he's the best programmer available on the planet. So would you hire this guy? You know him, right? I'm assuming you do. Linus. This guy is the person who created Linux. So I'm talking about that guy. Would you hire him to write a hello world program?
Too expensive.
Sorry?
Too expensive for the menial task.
Extremely expensive for a menial task. You cannot, right? So that's what I think most companies, most organizations try to find, is they find the appropriate skill level, appropriate money level, appropriate ability level, interest level, willingness level to match a given task, and then they fill that role. What does this also mean is that by the time this guy's, the F person, where is that guy? Here. This F guy and his counterpart, not the A person, but maybe F prime. These guys are busy doing their slow work. And by that time, these guys are having fun. They're probably idling, having fun. They're sometimes idle. And go do something interesting that they find interesting. And so as a consequence, you will find that if you have the behavior in the organization where a couple of people are just having fun playing ping pong or doing something else, like having beer on a Friday, some people cannot join that party because they are busy working on a Friday afternoon. They cannot really go have the fun part. And so that becomes a cultural issue in your company. So what do you do in that case? There is no simple solution to this problem. The only real true problem that a true solution, if possible, is to automate. Automate the boring stuff. the repetitive stuff and put your people on work items that actually are designed for people. Don't make people do boring stuff. That's a simple way to think. It's hard to accomplish. You can automate many things and people are doing it. You have seen, I think, if you haven't, let's see, Elon Musk, Model 3, 10th of speed. He just tweeted, I think yesterday, with a video of slowed down Model 3 production video. So here's a tweet coming in from Elon that shows you, look at this tweet, and I'll just paste a link for you. You will see it. I'm not playing it here right now, but I'll just paste it in Slack chat. You can play that. The idea is he has automated manufacturing supply chain of his cars in a fashion that there is no people involved in that situation. Now, is that a good thing or a bad thing? That's the question I think a company and also the society need to answer. I'm not going super political here at this moment, but all I'm saying is look at this link and understand that what he is doing is automating the boring stuff effectively, putting his Elon's people, these F people, on more interesting humane tasks. If you have a person who is in charge of tightening the left front wing nut, and by the way, I have met such people, the left front wing nut, they tighten this in an automotive assembly line. So you have this car here. It has the front and the back and then 4 wheels. And so for this person I met, he tightened the left front wing nut in this portion of the car for 22 years at Ford Motor Company in Michigan. I met that person. That's all he did in his life. Now, that is something that is unfortunate. Like, he is a specialist in tightening that one piece in the automotive supply chain, and he's doing that one task. He knows exactly how much torque, how much pressure, what foot-pound of force that you have to apply to, the appropriate tooling needed, everything he knows about this one item. That is not how we should treat people, because people can do better things. People can think. And that is, I think, what we should reshuffle our people to make people think, to not make them do boring, repetitive work. Anytime you find something repetitive, you automate. And it is about you automating yourself, I think, is the idea I'm really trying to drive towards. This companies may not automate certain boring, repetitive work. But let me tell you examples that we have seen, that I have seen myself, where employees in companies like yours, employees should consider automating their own job, and thereby basically preparing the groundwork to get laid off. Honestly, that's what I'm really saying. Automate their own job. And when you do this, what happens? What happens when you really automate your own job? Completely automate, make your own current job automated. What happens?
If you keep it a secret, you get to do nothing while your work gets done accurately.
Yes, exactly. And that is what I'm saying is you should, by your own intention, automate your job away in a manner that you will not be required in the job anymore, that the company should actually lay you off because you automated your own job. This is the way to continue to have a real job all the way forward. If you don't do this, you actually are likely to get laid off. If you actually automate your own job away, you're likely to be given another job to automate. That's the real point I want to drive to you, is to basically think about whatever you're doing in your company. If you're doing it for a couple of times, maybe a couple of years, if you will, try automating. Try to replace yourself in your own current job. And that is the only way, I think, today that you can actually sustain to have a good job going forward and grow with your company, helping your company in making money from your customers. And thereby you will eventually make money as well. And I think that is the goal that I would like to have you think about. Because this is one very clear way of, what I call in, say, 20 years ago, people worked for a company and they still work there. And that's changing, honestly. That's not true anymore. These days, it is actually not the case that you will expect a person to keep on working for a company for more than a couple of years, handful of years. People go, people move away because people want change. People want change coming from within. They don't like change forced upon them. And that is what I think. My summary to you is this: automate your own job. Keep that in mind. You should do that for yourself so that you are effectively saying that I am not needed in the company anymore. And so either I can go bye-bye or you find me another job because I will automate that one also. That's, I think, the key takeaway from this discussion. Let's finish off on the idea of anything that I may have missed in that book summary. I'm going back there and catching up. I think you already know these things.
And the beauty of it is you can fix the automation when it breaks, because that's the thing, is it does break.
Yes, yes, it does. Absolutely. Everything that you can think of will break, especially at the time when you need it the most. This is called Murphy's Law. So Murphy will strike, and we'll talk about Murphy and in the third segment. Murphy will strike, no doubt. And he will strike at the moment when you need your thing to not break. Exactly at that time, Murphy will come in play. Murphy's Law. There is law. There we go.
Hey, Nilesh,
Yes.
that's my, that MSD 2053, that's me, Mark, just FYI.
Oh, this one, MSD? Okay.
Yeah.
Got it. Thank you. Thank you. I was not curious. I was not even looking, but thank you.
Yeah, Stookums is my evil cousin.
Yeah, I know that guy. I've seen him. So, yeah, I met him for coffee the other day, I guess. So, yeah. So here, I'm assuming you know Murphy's Law, so I'm not going to read it. Basically, it's as simple as that. If you have a bread, you put a layer of butter on one side, and you accidentally drop the bread, how will it land, this way or that way? You know the answer. That's what I mean by Murphy's Law. So the butter side will go down when you have dog hair on the bottom, it'll stick there and nice. That's Murphy's Law striking. And so let's finish this book discussion because I want to move on and not talk too much theory, but do some work. So I think I did not skip anything here. And okay, let's quit. So I'm quitting from this theoretical discussion, which I think is a necessary discussion. The key summary, as I said, is remember to automate your own job. In our bootcamp, this bootcamp, in your companies, I have seen 3 people that have done exactly this. And they have automated their own job. The company, unfortunately, did not find them another job. So they were able to find another job in a different place. And they have done phenomenal work. And that is, I'm happy about them. So we'll talk more about those things if you're interested, but not in a session separately. Having said, what I want to now do is a quick recap of what we did with Chef and now focus a little bit of Ansible and then jump into more of Docker. That is all what I want to do. So we covered ground quite a bit with using this technology. We briefly touched upon one exercise using Ansible. And there are more such tools, and the tools will keep on coming and growing and sometimes going away and things of that nature. They evolve. Evolutions happen. What we did with this product was that there are 2 ways of using it: the solo way and the client server way. We practice both methods in terms of making a particular setup to accomplish. Our goal with these tool sets is kind of similar. What we have is our desire that we have in mind, the outcome that we expect. We make that outcome bring to life. We assign that desire to a new machine or a collection of machines and say, hey, you go become what I desire, and it becomes that. That's the kind of usage scenario that you have in both solo and the client server combinations. This is an open source product, and so are these guys. Some elements of here are not open source, so just check with your legal teams about what that means to you. And I'll leave that for your company to decide. Now here in Ansible, the model of usage is somewhat different. The Ansible tool we used it, requires nothing. Actually, it requires nothing to be installed on a box to begin with. You notice that in here, as well as here in Chef, you had to actually prepare before you could cook. And this prepare and cook is together known as bootstrap. And prepare basically means the install action, and cook means the run action. And so these two things are necessary for Chef to function. The preparation step is a critical required step. Without that, there is no Chef, so you cannot run it. However, in case of Ansible, the good thing, the one thing that I really like about Ansible is that there is nothing to install. The only thing that we have is what we use, so it's already there. It is called SSH daemon. It's already there on a Unix box. In Windows machines, there is WinRM, which you may or may not have heard of, because many people in Microsoft do not know what this thing is, unfortunately. It is a Windows component. It functions very similar to this SSH daemon that you saw. WinRM is basically Windows remote management. This is different from what you see here, remote desktop. This is not what I'm talking about. You have seen remote desktop. I can go connect to a remote Windows computer through RDP protocol, and I log in and all that good stuff. You have seen this, you have done it in your company, very likely. RDP, also known as Microsoft Remote Desktop, also known as MSTSC, I think, MSTSC. This thing is remote desktop commercial. You're very familiar to this idea. I'm pretty sure you know this. But what you do not know is the other idea which I'm talking about, called WinRM. It is a command line access to a remote machine, just like you saw in SSH daemon. WinRM is also a part of Microsoft Windows Server-based solution set. Very few people actually know about it, even inside Microsoft. The people who deal with it are absolutely, the people who make it know it. Some people know it, but not everybody knows it. As compared to this idea, which I just mentioned, almost everybody seems to be aware of this, which I'm assuming you also do. This is like a remote desktop setup where you can connect with and remotely connect to a Windows machine like I just did. And this is not what we expect to be running in the context of cloud, because first of all, let me show you this thing called the Windows thing, Windows Server Core. So there is a product in Microsoft called Windows Server Core, which is what you see here in this table. It started with Windows Server 2008 timeframe, and it is available in the cloud as well as in enterprise editions. You can see that this is available only in the server installation of the operating system, not the client pieces. You don't see them in client. Now, what you're looking at here is that it doesn't require. It is similar to what I think I mentioned briefly. Did I discuss this idea of just enough operating system before with you guys? Where bare minimum operating system that you need to have, which is as small as tiny as possible. Did I discuss this at all ever?
Yes.
Sorry. Okay, I did. So, okay. Did we see some examples of what JEOS is or doing? No. So here are some examples of JEOS. Like CoreOS is a good one. Ubuntu JEOS is another one. These are what you see when you go to, say, DigitalOcean and launch a machine. What you get is so let's go to DigitalOcean and launch a machine. What do you really get from these choices that you see when you create a droplet? These operating system choices that you have seen before in that picture that you're looking at is the bare minimum. The bare minimum operating system that is needed for a couple of critical things to function, such as storage, networking, basic input and output, and what else is needed? SSH connection. That's it. Pretty much that's it. And you will notice that I did not include any display related components. No display. Not needed. There is no need to, because you can always remotely connect to it. So there is no display graphics card, no nothing, no need for a monitor, because there is none.
No
All you
MP3
do-
players?
Sorry?
No MP3 players?
No, no MP3 players. Correct. So no audio, video capabilities, no nothing, just bare minimum machine, bare minimum operating system. That is what you can find in this example. Like, we saw and used this example in one of the exercises. This is a good Linux variation, Linux distribution called Core OS, which is minimal, tiny, and it just is a good example of what a just enough operating system is going to be for a usage model. The idea of Core OS is basically it is Linux, and it is designed to run containers. That's where this comes from, the Core OS operating system. It is Linux, and it runs containers. The one thing it does is just run containers. That's the whole purpose in that particular operating system. You can see other operating system examples, JEOS here, and this is Ubuntu Juice, which is pretty much the bare minimum Ubuntu you can get. And what you're looking at here is Windows Server Core, is the juice of Windows. Now, this word juice is pronounced in a way where this guy particularly first time said, Krishnamurthy Srinivas. He used that word, I think, and that article is not available anymore for some reason. But he I think, first said in VMware conference somewhere, he used the word juice, get juiced. The idea is just enough operating system pronounced as juice. The word juice has no meaning there as such. It's just a fun way of saying this thing. Just enough operating system, juice. There's no meaning to this word as such. So that's what Windows Server Core is just the bare minimum operating system, which has storage capabilities, network capabilities, input-output capabilities, and WinRM. That's what this Windows Server Core is going to be. So what our Ansible tool does is it assumes that you have WinRM, which you do in case of Windows, and assumes you have SSH daemon in a Linux machine or Unix machine, and you have basic capabilities of the system that you expect to see there. And therefore, the core benefit of using Ansible is nothing needed to be installed. It just works. Except that I just said it just works. But that is not really true, because you have seen problems in the past where I try to run Ansible and it says Python not found. That's a problem, isn't it? But the challenge that we are looking at in the industry is Ansible uses Python 2, and some operating systems have moved on to Python 3. So we have to still have a extra flag indicate that, hey, please use Python 3 with these machines. So that we have seen that example, right? I ran into that problem. So nothing needs to be installed is kind of a marketing spin way of saying that, hey, it is nice and good, and you don't need to install anything. But actually you do. You need to have Python there. Otherwise, Ansible will not work. You need to also have these guys, SSHD, which are expected to be there, no doubt about it. These guys are expected to be there. So that's how you should, they will claim, these guys, Ansible will claim that, nothing is needed to be installed. And that is kind of sort of true, but not technically absolutely true. And so you can keep going ahead and look at the documentation of Ansible. It'll further describe some of the things that I want to actually talk about here briefly. So where is that documentation? Docs.ansible. And here you have the Ansible core documentation. So Ansible Tower is a commercial product, conceptually similar to Chef Server, if you will. So we are not touching it since it's commercial nature. So we'll stay on Ansible, its core functions, which are available in the open source, and the module index that you're looking at here is the best resource in this documentation. We have, I think it has about 300 or so modules, different modules that will allow us to accomplish a variety of scenarios.
Hey,
So yes.
You mentioned earlier that since Ansible doesn't have a client-side daemon, you mentioned that. Like, what's the downside to that?
It's actually a good side. The good thing is that most corporations like your company Boeing will be very, very critical of allowing anything inside your company coming from the outside. Like inside the company boundary, you want something to come in and run on my data center in my production machine here.
Right.
They are very critical about this thing that, hey, you want to run what again? You want to run Chef Client? What is that thing? I don't know. I don't trust it. That's the question people will bring up.
Having Chef Client instead of Ansible. Like, I mean, there's got to be some reason that that the Chef and Puppet style model.
I cannot hear you. Hold on. Let me see. Let me adjust. Brian, yes, please ask the question again.
Sorry. I said I'm assuming that there's some reason, though, that the model that has the client-side daemon is still so popular with like Chef and Puppet, though, right? Like, pros and cons, I guess.
Yeah, there are pros and cons. One of the cons of having a client-side daemon like this guy is that corporations do not like this foreign object. They don't trust it. To them, it's a foreign object. I don't know what daemon you're running on my production machines. I'm scared. I need to know. And that's one of the pushbacks that typically people will receive when you want to inject your client, like a Puppet daemon or a Chef client running on all my production machines. Are you kidding me? I don't know what this is.
There is a similarity here. The Python interpreter could be considered like the Chef client-side agent, but I guess it's generalized enough as a language that it's acceptable.
Yes. The way to think about it is that Python is considered a part of the operating system distribution, as opposed to the Chef thing, which is coming from a company from Seattle. That's the difference, right? So it is thoroughly vetted when it comes from an OS vendor. You can think of OS vendors as Microsoft or Linux distributions of a variety of types, basically derived from the Linux core. And then you have the Apple company and the Android company, which is basically Google. These guys are together, right?
That's a good question, though. Why not just the Bash interpreter, right? Because that's even simpler.
Yeah, it is going to run Bash interpreter effectively, but you need Python to make your life simple. What does that mean? It means, here, let's go pick some module like there, file module, right? You want to set a file, so you want to say, you've done the file in line item, right? So see, if you want to run this kind of an example of modifying a particular file in a particular line in a particular file like this, and you try to write this in Bash, it's daunting nightmare. Here you can write simply with 4 lines of code and a segment saying line in file. Look at the regular expression, line beginning with listen, and replace it with listen 8080. Boom, you're done. See how succinctly you're able to write things like this to make your design readable and understandable and usable and therefore implementable. You can write, of course, you can do every single thing in assembly language as well, but
right,
you cannot do it, right?
So it's shorthand. It allows us to do a shorthand that's easier for a user versus a right. I gotcha.
The reason you go this way is because what you write, what you write in your repository in a Git repo, when you describe that YAML file, like we mentioned before, in that YAML file, if you look at, I'll pull up YAML right now. You will find that once you are familiar with this kind of a writing style, this type, that your YAML file becomes your document of record, document of design. In terms of, it is almost like English readable. If you really look at this, it is very easy to digest. Not complex, small chunks of segments of code where you basically document what your infrastructure is going to be like. You're writing your infrastructure design in simple YAML here with various constructs defined and they're very nice and tidy and small and readable. That's what makes it interesting, is they're easy to digest. So you write your design, you document them, and then you don't have to separately do anything else with it. You just play the YAML file. When you play that YAML file, it automatically implements your design And this is the idea that we are talking about. I would call it as infrastructure as code. You write down your infrastructure design elements as code here in the YAML file. And then you just play the playbook and you implement the design. As simple as that. Compare this with Chef. You had a lot more things to deal with and lots of other variables to deal with. So you had cookbooks, roles, nodes, and this and that, and it's complex. And you saw it, you did it. The simplicity of Ansible makes it interesting. So it is easy to apply this and easy to share with other team members. Hey, can you accomplish this thing? So the person reading can really understand very easily, like, oh, I need to find a line called listen in this particular file and replace it with listen 8080. Got it. I'll do that. How do I do that? Don't worry about bash scripting. Just use this segment and apply that play, meaning play this particular play, this portion of the playbook. You play that on a machine and you will have that thing happen. And you will have this thing happen in an idempotent fashion, which is you repeatedly run the same play over and over and over again. You will always have this file containing a line saying listen 8080 all the time. It will maintain that state. That's what you want from an infrastructure design perspective. Is you write down your ideas in a fashion that are easy to read, like this YAML, and then you keep that in the state that you want it to be. So you're basically documenting your infrastructure, writing that down in form of simple code like this YAML code, and playing that play easily. And while doing that, you're not requiring your companies, like big corporations, to inject foreign objects into their production infrastructure. Imagine another small company, right? Let's say a company in Issaquah. They go to Boeing and say, hey, I want my piece of software I wrote for you, and I want you to run in your production environment. What will Boeing say? That's what I'm talking about, right? They will say, yeah, exactly those words. So basically, nobody wants to inject foreign items into a production startup. They want to deal with everything that is already vetted and known. And they trust a operating system vendor way, way more than they will trust a small company in Issaquah. They'll trust Microsoft, they'll trust Linux people, they'll trust Apple, they'll trust other operating system vendors because they have been in business for years and the whole world uses it. And they go through certain extra steps to make sure that the operating system is actually exactly what it claims to be. And there are reviews and lots of other things happen in construction and creation and productization of an OS. So a component that is a part of the operating system is considered to be highly stable, tested, trusted, and all the characteristics that you would expect to run in a production setup, but not as much as an item that this Issaquah company wants to come up and sell it to me to do what? Again, put it in my production machines in my company? Are you kidding me? No way. This guy will basically be kicked out. However, in case of Chef, companies still use it. The reason they use it is because a variety of things. They seem to like Chef. They have people running and managing their infrastructure using Chef. That Chef is open source, that they know the code, that they have seen the code, they have reviewed it. They feel comfortable running it. They have seen other people with the example of running Chef. They have seen Facebook running Chef. So Boeing might say, yeah, I might actually run it. And so Boeing might experiment. By the way, there are a bunch of names, big name companies already available here. You can see who uses Chef. So who uses Chef? Let's go find out. So you will see a list. And yeah, customer archive. So the long list of companies that uses, they publish. So GE and IHG and banks and Facebook and a bunch of other major players apparently use Chef. And so is who uses Ansible. And so here is the who uses Ansible use case overview. 28 companies that are using Ansible. So you can see that list. So here are some. However, this is not what you should think about. From your perspective, how would I go and how would you go thinking about, hey, where do I put my energy, my effort? Should I study Ansible? Should I study Python? Should I study Puppet? Should I study Chef? There are so many things to do. What do I do now? That's the real question that most people have. And what do I do? Shut up. Forget about these big companies, Boeing and Microsoft. Forget all that. Tell me, what do I do? That's the question most people ask. And so here's how I will give you a framework of thinking about how you should think that I think is individually useful. So the way to think about as an individual, what do I do? What do I study? What do I invest my time, my energy, my resources in a direction that is directly benefiting me? Because it is all about me, right? That's how it is. That's how society is. So I will go to an example site, Indeed.com, and look for trends. You may have seen this before, but I'll show you my perspective on using it. So this is your Indeed.com/job trends website. Now in there are these buttons. You should just try them out. And then begin with an empty slate and add a term. And here you should add terms like chef, for example. And so you can see a trend graph. By the way, there are no historical numbers, but when I started using chef, this chef line was like steep uphill, like really steep uphill. Right now it is kind of stable and fluctuating up and down a little bit. With percentage is not much in terms of growth. You see some recent numbers growing up, but it is again very tiny. It used to be a rock star product when it was kicking off just 7 years ago when it started. And I saw it booming up. And this is the exact chart that I look at and say, hey, this is interesting. I should study it. Maybe I can do something with it. And that's exactly what I did, is what our bootcamp up until now in the DevOps segment is full of chef exercises, because they have been building and accumulating over the years. So I've been using it. But over time, what I've seen is this chef trend is kind of stagnant, if you will look at this. Just by looking at this chart, what this chart is telling me is that number of job postings that require chef, that has the mention of chef as a keyword in their job description, is not dramatically growing anymore. That's my observation from this chart. Okay, I remember that. I'll remove the term, put the word Ansible, and see what happens. You see some growth there. You see the uphill climb. And just a couple of years, the growth was like dramatic magic. It came down and going up again. So it's a recently developed product. Will last 4 or 5 years, not as old as Chef. And you see the trend is going up. Okay, you note that. You remove the term and put another term there, Docker. See what happens. Aha, now you're talking, right? Something is happening in the industry. What is going on? Containerization. So I should focus my energy in Docker more than Ansible, and more in Ansible than in Chef, and like that. Should I, say Microsoft Word? Let's say if I say Microsoft Word, see what happens. Yeah, it's not much of a skill to begin with, right? It's a lame thing to know. I mean, everybody knows what's the big deal. So that's how I think. Now, I'll add some more keywords to you. You will find these keywords, buzzwords floating around. People talk about it all the time. Like I said, Docker, Swarm. Yeah, so it's a recent phenomenon, and you see some spikes coming up. Okay, let's see another keyword, Kubernetes.
There we go. That's what I want to know about.
Yeah, there we go. So it pumps up right away. It's steeping, steep uphill climb. So what is going on from my perspective is what I should focus on, right? That's how our open economy works. It's all about us, individuals and enterprises. Everybody is of their own interest, and that's how economy works. So you look after for yourself, and you find out what should you spend your time the most on, and you make your decision. These charts will basically give you some guidance according to what Indeed.com thinks, what they collect from their job portals. And it's a reasonably good indicator. By the way, this is how they can choose my technologies to cover in our bootcamp. This is exactly what I've been doing for like several years now. So ever since I find technology, I see if it's interesting or not, and I'll pick it up. I'll study it on my own, go to GitHub, practice it, learn it myself, and then teach it. Let me tell you one thing, which you may be surprised. I did not go to Cloud Genius, and I did not study cloud computing, and I did not work in the cloud arena in Microsoft. I have zero cloud experience, and I'm proud of it. That's what I just told you. Does that ring a bell? I don't know. I let you decide. I think I know my stuff because of me practicing it with bunch of people, and that's how I built myself. I have zero professional experience working for Microsoft Cloud, none at all. I did not go to cloud school or any kind of school to just study cloud computing because it did not exist. I went to this school, which is, by the way, a very good school. It's called the Computer Science Department in Indian Institute of Science, and that's where I'm from. And yes, it's a top-notch school, no doubt about it. I'm not saying that I did not go there. Yes, I did. But honestly, you don't need to go to a school. At this school, I went, I think, in what? 1990. So it's a long, long ways ago. That's where I went to computer science. And after that, I have been doing on my own mostly. So the cloud did not exist at that time like we see today. So these technologies are recent. They have a simple takeaway from what that means. That takeaway may not be apparent. I like to clarify what that takeaway is. When I said these technologies, like I mentioned all these buzzwords, like all these things that we searched on that website, they are recent technologies. What does that mean? What's the takeaway from this word of recent? The recent reference basically means this one thing, that nobody can claim that they have 20 years of experience with Kubernetes. They cannot claim that they have 20 years of experience using Kubernetes. If they are claiming like that, they are bullshitting. What does it translate to you and me and to everybody? Is that we are at a level playing field. Level playing. There is nobody who knows or rather has more experience than other people because the whole thing is new relatively. If you look at the Kubernetes release date, let's see when Kubernetes came out. I'm just picking Kubernetes as one example. It applies to the idea applies to anything in general. Kubernetes release date, version 1. See when it came out. So here is the version 1, 2015. So it's like 2017 right now. So Google releases Kubernetes 1.0 container management on OSCON July 21st, 2015. That's the date. So mid 2015. So people have 2 years of experience. Now let's see what this graph says. The graph actually starts at mid 2015 right there. And then it's picking up. You can see the growth right there. So what does that translate to? Is if anybody is claiming that they have like more than 2 years of experience with Kubernetes, they are full of themselves. This is reasonable. This is not. So what does that translate to you? It basically gives you a level playing field, meaning everybody is on the same level. Nobody is, has an advantage over you. So it all boils down to you practicing and getting to a point where you can actually compete. And if you compete, you win. Because you can, because there is so much demand. You actually are very likely to gain what you need. You can get it, absolutely, no doubt in my mind. Only thing that is needed is practice and clarity of understanding. That's all it takes. If you understand a thing clearly and you practice it, you get what you need. Simple, very, very simple idea. There's no rocket science behind this. You just have to understand what it is and practice it. That's it. That's it. And I know a couple of you are really, really sincerely doing it. And I'm so proud of you guys. I know you know who you are. You're practicing a bunch of things on your own, even if I'm not covering it in the boot camp. You're still doing it. That is a phenomenal thing. You should keep doing that. Absolutely. Having said this, I will conclude this discussion and then jump onto an exercise of Ansible that I think I have, and I will. What I plan to do is take that Ansible example. We will use a method which not just uses these modules in Ansible, but also takes on a role. A role is like a collection of playbooks. Collection of playbooks. And modules are individual elements that go inside a playbook. So I'll show you examples of what I mean by that. And what I want to be able to do is use Ansible to allow us to transition our discussion to using Docker on a larger scale. So what I want to be able to essentially do is use a ready-made role here, which is basically a collection of playbooks. And these roles are available on the Ansible Galaxy. You have seen it, I think, before. I mentioned a bit here, a thing called Ansible Galaxy. So we'll go to the Galaxy, and here we will find that there are ready-made things. Like we can explore and browse roles, and in the roles section, I will go search for Docker, and there I will find something that I like. For Docker, I think I like what? Where is my favorite? I think his name is ANGSTWAD. That's his name. Let me search him outside on GitHub. It's easier to search. Yeah, this guy gives us a ready-made role. And so it is also available on the Galaxy, and it's right here. You can see that this is the gentleman, and his name is Paul, and he apparently loves Python, therefore uses Ansible, and he has prepared a role for getting Docker on a Linux box, Ubuntu specifically. That's the role I want to use today. What this role is a collection of playbooks. So here is a default playbook called main.yaml, like that. And so there are some things here. We'll go read them in great detail and understand what it's going to do for us. Our outcome we expect from this game, this Galaxy-based book that I'm looking at, Galaxy-based role that I'm looking at, which has a bunch of playbooks, which playbooks include these modules. And what this particular role, when we play it on a box, that you will have that box magically convert into a Docker host. And once we are in the Docker land, we can then do our own Docker stuff on a bunch of machines, all connected together, either forming a Docker swarm or a Kubernetes cluster or those kind of things. So what I'm going to do right now is to use Ansible to help us understand what a role is, how do we put that to use, and then use that to construct a foundation where we can get a ready-made Docker machine, a machine capable of running Docker and is already running Docker. Docker machine is a separate product. We'll talk about that separately. So the goal will be to produce a machine running Docker using this particular role. The role, I'm going to paste it in Slack chat. It's right here, coming up to you right there. And that's the role. I will be using it, and I will understand how to use it by first reading the README. It describes me how to use it. And here is an example play. See the play, how simple it is? Run Docker Ubuntu. Where do you want to run it? On these hosts called Docker. And what do I want to run? I want to run this role. Which role? This role. That's it. This is our playbook that we will run. Everything else behind the scenes is already done for us by this gentleman. And so you can see more advanced examples. It's fairly elaborate to see it, but I want to bring that role down. I want to first of all start my virtual machine. And in there, I will bring that role down in a folder. For that, I need to have a setup, some kind of a preparatory steps I need to be able to do in order for me to use Ansible. And you know the number of things you need in running Ansible compared to number of things you need in Chef are different. Ansible is very simply requires basically one file called Ansible configuration, ansible.cfg, that you have, I think in a past example, we have seen that. So that is what I will be using, creating from scratch, and see if I have a ready-made example for that already. Let me just quickly review if I have a ready example for you to refer to in our website. Let me find it quickly. I think I might have it written down somewhere, but I have to find it first. Yeah, there it is. And all it has is this Docker Ansible link, which is an exercise prepared already. So I am going to clone that exercise. So here we go into that virtual machine, and I'm going to clone this link instead. And so I will go to the VM in there, open up, and clone. And in my current computer, I have these files. You see that I have this chef manage, which I'm going to now, just leave it alone there. But instead, git clone this new exercise, which I'm bringing it down here. It's coming. It came. So I can see that there. This is the folder that I want to work with. Give me a second. Microphone, I forgot to put in the right spot. So this folder I want to work with. So I will open up in Atom. Sorry, first I go there and then open up in Atom editor and see what it contains. So it contains very few things, apparently, just some simple things to get us started. So we'll put this on one half and the command line on the other half, like that, and then read what we have. So here we have a file called Ansible configuration. That configuration defines that I need to put all the machines that I want to configure in this file called inventory/hosts, which is basically this folder, inventory/hosts. And it has one file apparently, or rather one machine reference. So I'm going to read it out for you. I'm going to zoom it a little bit so you can see the whole thing. And so I am looking at that one, right, like that, expanding it, and looking at the entries in our host file. This file I'm talking about, hosts. This file has a reference in Ansible configuration. This Ansible configuration is the only file that dictates, the entire play of a collection of playbooks in your Ansible folder, like we are dealing with this example called Docker Ansible. So anything we do in this exercise will be controlled by that Ansible configuration file right here. And let's go read that. In that file, you will see that there is this host file reference, which points to this particular file containing all the hosts that I want to play my collection of playbooks. That file is this file. In that file, I have just one example. The other example is a comment. So you can uncomment it. But for right now, this is the example. This example has a name, an IP address reference, an Ansible user reference, an Ansible private key file reference. As you notice these things, similarly here we have, let me uncomment that. So here we have an Amazon example with a IP address and a user reference. The user is again different. This was root here in this cloud, DigitalOcean cloud, and that cloud it is Ubuntu. You can prepare basically similar examples just like that and say, I will choose another cloud. And here I will say it is my Google cloud. And I have a different IP address here. Sorry, IP address. So, and the username could be whatever I like, say Ubuntu, or maybe root, and the private key file, and like that. Similarly, I can go on adding a variety of clouds. Basically, it's agnostic to cloud. It doesn't matter which cloud you're looking. Why is Windows came in here? Okay, hold on. So, and agnostic to other clouds. I can just put any other machine in Amazon cloud. It doesn't, Azure cloud. It doesn't even matter which cloud you're using, because as long as the machine has Linux and an underlying user and a private key corresponding to it, you can get all these boxes configured the way you want according to what you define in your playbook. For right now, I'm just picking up one example and commenting out the other three. By going like this and say, hey, hold on, comment and comment and comment, just using one line right now. You will also notice that Ansible is changing
it has removed the references to SSH all over the place. So what I'm going to do is remove those references like that. All these blue highlights I will delete because they are not there anymore, or not needed anymore, I should say. You can keep it, but the newer syntax actually has this terminology is slightly different. It says Ansible user, Ansible host, Ansible private key file. There is no reason to call out SSH explicitly like this. So I'm going to delete that. Go. And this is how the new syntax is going to be going forward with newer versions of Ansible. So I just made that one change. Another change you will notice is Ansible configuration, this host file reference. This is also changing in the newer versions of Ansible, which I think I have here in our machine. And so this needs to be inventory. Inventory. And that is how you call out your inventory of machines that you will deal with, like here. So back here into configuration, we have to specify our role path. This is the path which this particular thing will look for in a folder which doesn't exist yet. It will be called roles. It doesn't exist here. It will be created like this, roles. And that is the folder that will be used. And that's what I will be using to store my roles, which I currently do not have. But if I don't have it, like I just created, it will get created. So I can actually delete this because it will get created when I want it. So you don't have to have it. You can just specify that that's the folder name I would like to use to store my roles. And I'll say, fine, use it, use that name. Then I have this ask become pass true is a question of whether I want to ask super user password if I am trying to escalate my privileges. I'm assuming that you understand when I say escalate privilege and what it means. In Windows land, it means something like this. If I say right click and say run as administrator, what I'm doing is escalating my privileges to the administrator level, and I say yes, and then it is an administrator command prompt. That's the Windows equivalent of the same thing that you do in Linux. And how do you do in Linux? You say sudo something like ls, for example. And so sudo will ask you for a password, escalation of privileges. So I type Cloud Genius. And that is how I was able to get a super user run of ls command to get me the listing of the current set of files in the current folder. This was super user escalation. That is exactly what a become user or become pass means. You want to ask become, basically think of become as super user permission. You want to become the super user. That's how the thinking behind this phrase is. You want to become a super user, and you want to make sure that the machine actually asks you for a password. When you become a super user, you want to actually keep this as uncommented. For our example, we don't need it, but I just wanted to let you know that that's an option. Host key checking, I'm basically doing the cheating route and marking it false, because I don't want to actually keep on typing yes and yes, I know what I'm doing, and yeah, go ahead and connect to the machine and all that. So I'm basically saying, yeah, ignore all those host key checking and mark it as false. Deprecation warning, I also marked it as false. I should mark it as true because you will know what is going on in Ansible land, what feature sets are getting deprecated. And so I'm basically going the strict route and marking them true so that you understand that host key checking is enforced. So SSH key has to match, otherwise you will have a problem. The problem can be eliminated by removing your stale entries like this, rm-rf in the known host file. That's where it contains all these stale entries from previous exercises and previous machines. You remove that file, and now you don't have any known hosts. So this host key checking will basically ask you, hey, are you sure you want to connect? And you have to say yes, and then it proceeds because you're going to check for that. Deprecation warnings, you will receive them because I said true. Anything that is slightly older in the way you write, it will be called out. And they will issue you a warning that, hey, you're using the old way of doing things. So that's what I'm trying to make sure that I get alerted for. And that is pretty much it in this Ansible CFG example. We have a roles path defined in the folder called roles, inventory defined in a file called hosts in a folder called inventory. You can keep this file anywhere you like. but I have decided to put it in this inventory folder. And underneath there, I have a specific host variable file. What I'm doing is making some customizations in the variables part of that particular reference. What I'm doing is, as you saw in my host example, this user reference is different for different clouds. So for example, in this Azure cloud, I can choose it to be whatever I like. In Google Cloud, it is going to be Ubuntu. In Amazon Cloud, it's going to be Ubuntu. In DigitalOcean Cloud, it's going to be root. So therefore, I need to let Ansible assign override usernames for the user that is going to be logged into as you connect, and also define a path to the home folder for that user. That's what I'm calling it out here in the DigitalOcean Cloud genius.yaml file as a host variable reference. Similarly, for the other clouds like Amazon, the username is going to be Ubuntu. So here, and therefore the corresponding root location or the home location for that Ubuntu user in Amazon Cloud is home Ubuntu. That's the home folder location. And the username, of course, is Ubuntu. That clarification is different for different scenarios. So I have two different host variable declarations differently written down. If you're dealing with other clouds and you want to modify something for specific cloud for a particular requirement for that given cloud, you need to include those variables like this, like in this example that I'm including here. And next, what I want to do is identify that I have a Docker YAML here, which is where I'm invoking my role, that role that I mentioned, angst toward that Paul guy, like I mentioned in the Slack chat. And there is a git ignore file, basically just simple things that I don't want to be, sending it to the Git repository. I just included this as a list of things that I don't need. So with that understood, what I will now do is pull down my role. That role I need is called out here in this example. So that's the role I want to grab. And how do I grab a role from that location? This particular location, which is Galaxy. And then find the role I'm interested in, is this role. So how do you grab it? Let's go see that. It's a one-line command. And it's not here, but I know it is Ansible Galaxy and then install. So that's where it is written down. Installation is basically this one line, Ansible Galaxy, install this particular role. So when you do that command and run it in your workstation, like here, you will see that the role from this guy, Paul, will come down and sit in a roles folder that will get created and show up in your Atom editor on the other side. So I will run it now. Ansible Galaxy, install that role from Mr. Angstward, this gentleman, this guy. He created a role, he's given it to the open source, and we are going to use it. So it's going to Galaxy and get installed, get that role downloaded, and shows up right there. And a bunch of things came along. That's how I want to grab that role and make it available locally. So that role is now available. What I want to do next is read this little bit about what this thing does for me. So I want to understand what this thing is and how do you use it. It says a comprehensive and ideally a sane way to install Docker on Ubuntu machines. So here is a brief overview of that, the version history as late as last month. So he's keeping it up to speed. And there are no failure comments here. So it says complete success. Nice. Let's go see the README file. So we'll go read the README. And he says, yeah, you want to install Docker on Ubuntu? Example play. This is how you invoke it. So I read that and I compare it with what I have written already. And what I have written is this versus what he says is pretty much the same thing. I'm just telling you that I'm basically using his example. So what he showed me in his README file is this. And what I'm running is somewhat similar. Let's see, compare. What he says is this, and what I wrote up on top is that. So let's go line by line. First, name segment. The name is basically convert an Ubuntu machine into a Docker host. So it's basically, yeah, the same thing. Yeah, I got that. So I delete this name reference. Next, hosts. Where do I want to run it on? I want to run it on all my machines. And this all is a unique keyword, which basically says all the machines in the host inventory. All of these guys, which are not commented. Right now we have 3 guys commented. These guys. The 4th one is not. So all means 1 right now. This is what this all means. And here is the host reference that he's calling it out. So that's what I'm doing in line number 4. Then I'm going to invoke this role by a role reference like that. And that is what I have done in line number 6 and 7. So basically I'm following his advice. However, I'm extending a little bit. And I'm saying kernel package state is present to make sure that the kernel package is installed and loaded. And Docker group member, please add this user, whatever that user is, Ubuntu user, Azure user, Google user, God knows what user, or sometimes people don't have a user, they just use root. All of these cases are fine. If you're using root, it's generally a bad idea. You know why? You should go lower privileges, not go root privileges all the time. But like, I remember Brian a couple of days ago, he asked this question about, hey, why do I have to type sudo every time? I have Docker installed locally on my Fedora box. That's what this line number 9 solves. What it is doing is adding the Fedora user for Brian as a member of the Docker group. That's what line number 9 does, which I think I pointed out a while ago to Brian saying, hey, add your user as the member of the Docker group, and then it will not prompt you for super user or sudo prompts. Without sudo, it won't run. So that problem, I think we solve it by hand, but this is how you solve it in Ansible. Line number 9. So with this, is all we are really needing to do is to basically run the play, and we have a Docker host. Simple, right? So I need to get a machine somewhere. I'll go here, look at my host, and this looks like a good example to begin with. So we'll say, you are wrong, dear. That IP address is broken. I don't know what my IP address will be. I'm going to create a new machine, by the way. And I'll put that IP address right here, right there. That's what I will fill it up with IP address. And then I run the play. And then I will see that my machine became a Docker host. As simple as that. So let's go run it. Running is very simple. The difficult part is understanding these things. Not really difficult, but just saying that running is simple. You just go to some cloud and say, hey, cloud, give me a machine, and I will make you what? A Docker host. So you give me a machine, and I'll make you a Docker. So first thing first, go to your settings area and double check whether your security has the SSH key in place or not. Like this key should be the one that you have in your virtual machine. If you don't have it, things will not work. You know this, but I'm just repeating that because that's a critical point many people run into. Having said, get me a machine, droplet. So I will say, log me out? No. So I need to say, get me a droplet, please. So create a droplet. And I just use the cheaper droplet. So here we go, cheap. And pick it in San Francisco and pick my key pair. And yeah, you are going to be my Docker host. You are my Docker host. And so I create that box and it just gets created. Now, as you know, just because I named it as you are my Docker host doesn't mean that it has Docker to begin with. It doesn't. It's just enough OS, JEOS, bare minimum operating system. And it takes me a few more seconds to get the machine ready, and I get the IP address from there, and then I go into running my play. And so that thing finished. I grab my IP address, copy it, bring it here, and put it right there, and save it. So when I save this, I should close that window by pressing Control W. And then also this Ansible configuration should be Control W. Don't keep these windows open because that's how you fat finger. Fat finger is a problem when you, by accident, like I know. Yeah, you must be laughing when I say fat finger because you saw you did it this morning earlier in the day. So one of you did. So yeah, it is fun fat finger to have. You in a knife configuration, you miss out one tiny little thing, and thing doesn't work. So that happens all the time. So that's why I'm saying, always when you're done with a file, just press Control W to close it out. Leave it like this, so you cannot accidentally mess it up. But let's go read what this Docker YAML does. As you know, we are going to play the play called Docker Ubuntu. How do you invoke this particular play on all the hosts that you have? You just run Ansible with that play, Docker YAML play. That's what we want to do. So first thing first, I will like to see if I have a connectivity. So with that machine that I just created. So I'll say, hey, let me do ad hoc Ansible runs. So some ad hoc runs. Ansible, can you ping all my machines? And what I'm doing is basically pinging, but through Ansible, using the Ansible ping module in an ad hoc command like this, not creating a playbook, just saying use the module ping and basically ping the box like this. No, not just the box, all the boxes, all of them. How many of them? One, all of them. That host file that we have, inventory file that we have defined. I should rename my language and not say host file anymore because Ansible has changed the word inventory. In the configuration, they call it inventory these days, not hosts, which is, I should remember to say not host, but inventory. So the inventory, we have an inventory of 1, and that gets picked up by the, the inventory reference, this IP address. And it says, are you sure you want to connect? This cross-check is happening because of the configuration called out here. Host key checking, true. So if I make it false and save and close and go back here and say no and break and then run the Ansible ping again, it will just shut up and ping. And it failed. It failed because Python not found. So what do I have to do for that? Python not found. Python is there. It's the version of Python that is not found. So Python not found means the machine out there is Python 3 and our guys Ansible, they use Ansible 2 by default. So we have to tell you to use, in our host declaration, we have to somehow communicate to you that you should use Ansible Python interpreter to be user bin Python 3. And let me just quickly check this line before I save it here. So I want to Google check. And there it is, a reference. How do I say that? Is there a typing mistake in what I'm saying? Maybe this line will give it to us. I think I'm probably okay.
You need an ER and an interpreter.
Yeah, there we go. So I'm going to copy this now. And there it is. Is there a difference in what I wrote versus they have? No.
No, you had an O for interpreter.
Oh, okay. Got it. Thank you very much. Yeah. Okay. So I need to put all this thing in a line for this machine that I'm dealing with. So I'll put it at the back of this line and all these guys also. So this line, and this line. And now I will reduce and remove this line altogether. So now we have a reference to the Python 3 interpreter, and we are telling Ansible, hey, you should use a Python 3. So it did not bother, did not bother checking our known host configuration. I removed it again. And you can see that if I now go back to here in my Ansible configuration and say host key checking true, and say save it and close it and run it again, and say Ansible, please ping. It pings. And it should have checked for host key references, but it did not. I think it did. What it did not check is force you to say yes. If you have a mismatch in what you have in your known host configuration versus what you see on the real machine out there, if there is a mismatch, that will fail. That's what that basically means. So this line reference of host key checking is basically if you know that the known host is actually known and good, if there is a mismatch, you should ignore that mismatch by calling it false. If you not call it false and say true, it will actually fail at that time. I hope that was clear. So I will save this and then proceed ahead with our exercise, which is I have pinged that machine successfully. What I would like to do is, by the way, this is just not purely a ping. You can ping the machine just like that by going to the machine and do an ICMP ping on that box. You could ping without Python. Our ping this time was through Ansible, so it required Python to be able to respond on the other side. So here, if you just ping like this, it pings, and you don't need Python for that. But if you're pinging through Ansible module Python, it is using the, now you see that prompt again, because I said true or false. What did I see? I think I set it true. So our Ansible configuration says host key checking true, and therefore you see this yes or no prompt again. And now it will go ping. And it is going to do the Pythonic way of pinging, and you get an answer back as pong. So ping and pong. Nothing actually changed on the remote machine. Nothing changed false. So having understood this part of running something very, very simply ad hoc fashion by typing Ansible, if you run it like this and say on all these machines, you run some module and say name of the module here, that will ad hoc run that module on the command line for all the machines you have in your host reference or inventory reference. But that's not what we are doing. What we are going to do now is to actually invoke a playbook. The playbook that we have in mind is this book right there. It's a very simple book. It invokes a role. The role is written for us by this gentleman. And so we want to invoke that role. How do we do that? We don't run Ansible, but instead run Ansible playbook. And then call our role that we have in mind, which is Docker YAML. So go run the Docker YAML Docker YAML playbook. It has the Docker role inside there. And so that's what we will do is it will invoke this particular role, which is given out here in this collection. And we'll read that also just a minute, but I will let the role run. So here we go, run. So it goes, converts that box into a Docker host and come back and say, report, I did it. And so this role is what is going on. So let's go read the role now. So in that role written by this gentleman, there is a default main playbook. It is basically doing all the things you would expect. Like, for example, check the signature of the location where Ubuntu packages are available for Docker, and set the apt repository. Identify if there are proxies that you have to go through to get to that point. If you have a need to install pip, which is a Python installer of packages, it will be automatically installed. If you need Docker Compose, I think the default choice is yes, you need Docker Compose, so it will install Docker Compose. The latest version, kernel update and reboot permitted or not. If you're doing it in production environments, you may not want to restart your boxes. You want to update the Docker package automatically later on, you can set it to yes or no. And you want to get the latest kernel available, you can set those things here. You want to install kernel extras, probably not. Unless you need it for a specific purpose, you can come back and change it or override it. That's the main handler. Now, if you go into detail, there are some other simpler handlers like start Docker, reload systemd, restart Docker IO. There are some meta variables defined here, like the author's name, his license, the platform used, Stretch and Jesse, and the Ubuntu platform used are Trusty, Janial, and Zesty. There are categories, development, packaging systems, and so basically, this is the elaborate way of writing a collection of books and giving it to other people for them to consume. And this is just one example. There are probably, I don't know, thousands of examples on the galaxy that you see. Lots of people are contributing stuff that other people can consume based on what they have found useful for themselves. And this is how you typically use a playbook or a collection of playbooks in form of a ready-to-use role. And we have seen that this thing seems to have finished successfully and reports back success has changed 9 things. And it completed all the 19 things expected. What does that translate to? It translates to that we can now connect to that machine out there in the cloud, and we'll say SSH root at IP address and connect to it. And here we have Docker running already. Oh, sorry, ps-a. So we have Docker running already. Docker info will show you the information about that, and that's how you convert a box into a Docker host. So as simply as that. So let's recap. What we did was took a machine out there in the cloud and said, let me exit from here, and said, get a machine in the cloud and said Docker playbook, Docker YAML, and run it again. And it will do nothing and come back and say, yeah, we have it. It will do 19 things and say, I did not need to do anything, so I did nothing. And then it says, yeah, I did nothing. I skipped everything. And so you already have Docker, so why bother? So yeah, I run it again, but I did nothing. That's what you're seeing doing right now. It is doing nothing successfully. And so that's how you use Ansible ready-made roles and accomplish a desire you might have for your infrastructure. You can accomplish this in a large number of hosts by basically going to another clouds. So let's say you go to Google Cloud and create a new machine and IP address and a username right there and operate the same exact way. Nothing else changes. Let's go to that exercise very quickly. We'll go to some other cloud. Let's say go to Google Cloud. So cloud.google.com. Or why these big clouds? There are so more exotic clouds these days available that I think you should know of. Scaleway Cloud. This is a cloud which is also available on bare metal. Bare metal SSD cloud servers in seconds. This is a company that I think relatively new. I like it because it is really, really, really cheap and gives you efficient way of operating with this cloud. The only challenge is that they are in Europe, not here, but who cares? So we'll play with this. Right now, I think I have an account. So we'll just log in, get a box, and convert into a Docker host, as simple as that. So here I'm logging in, and then I need to pass in my token, and then I need to get my SSH key, the public key out there. See, nothing changed here, nothing changed, 0, and the run succeeded. We can go back to our machine there and configure and confirm that Docker still exists, Docker info, and it's there. We can come back out and now cat our public key, because that's what I want to give to this other cloud I'm talking about right now. So this public key needs to be given to the other cloud. So here is my public key, copy it, and go to this new cloud I am talking about right now in the security section. By the way, this it doesn't go in the security. Where does it go? It goes to credential section. And in the credential section, I need to add a SSH key. And I say, okay, use this key. And no comment. That's bad. Hold on. Let me delete this. And delete this. And delete this. So I'm deleting all the old keys that I have and adding a new SSH key like this. And then this cloud requires us to give it a name like ID_RSA at the end. Apparently, that's how they write it.
Hey, Nilesh.
Yes.
I saw on that Scaleway front page that they were talking about having ARM instances. Have you ever used that?
Yeah, they work beautifully. Yes. Yes. This is the reason why I wanted to bring up this cloud. It's a new cloud. It supports ARM architecture and 4-core ARM architecture at a low price, and something that I think you should know and be aware of. So that's the reason I bring it up. We'll begin using a regular x86 machine to begin with. So I will go here and say, okay, give me a box. So just give me a box in Paris, and I can choose ARM. I can choose ARM 64, 8 GB RAM, and the pricing are really cheap, really cheap. But let's begin first with a regular OS. So here is a regular x86 architecture, and that's how I want to begin. And I will say, give me a Ubuntu Janial OS, and give me an IP address and a tag. And you can also get bare metal machines, by the way, bare metal hardware, ARM architecture, or bare metal x86 architecture. Or you can get intensive workloads with very high memory or very high number of cores. You can get, these machines are also available. And this is something I want you to know. That's why I bring up this topic. This is just a side right now, but we'll discuss ARM as well. My purpose right now is to just get a box and convert it into a Docker. That's what I'm really trying to accomplish right now. So I go Paris and say x86, give me a cheap machine running Ubuntu, or maybe I go choose Stretch, Debian Stretch, and there I say, yeah, create a server, please. That's what I will like to say to these guys. Give me a server. So they will give me a box in Paris with Debian Stretch with 650 GB SSD for €3 a month. It's pretty darn cheap. Having understood this piece, I still not sure whether do I keep my keys, because this is slightly new to me. So I want to double confirm my key pair credential, and I have the key pair right there. And I want to double save it, and it just saves. I don't know. I'm not sure exactly this is how you give your credentials, but I think this is the way. I think I'm not making a mistake. SSH key and say use this key. Yeah, fine. I think I gave it enough number of times. So back, create a server and call it, give me a box in Paris with x86 architecture and running Debian Stretch, and go do it. So here is the go do it button, create a server. So it should create a server for me. And there is my server IP address right there. And how do I connect to it? That's the command. And now let it start. So it is starting right now. Currently starting. Give me a box is currently starting with Debian loaded up. And I will run my play on that box as soon as it is ready. While it is getting ready, I will grab this IP address and go back to my workstation. And here I will say you need to create a new entry. Let's call you Scaleway. Scaleway Cloud dot. Yeah, maybe I should just name it what I named it. It's irrelevant. These names are totally irrelevant. You can call it whatever you like, or call me late for dinner. That's the favorite, right? And then Ansible _ host equals my IP address, which is this. And then everything else is kind of copy and paste from the rest. Like that. So copy like that and paste. The Ansible user is likely going to be root, I think. In this cloud also they give you root access. So save it. And the machine is called late for dinner. Ansible host is the IP address. The user is root. And the private key is the same that I have. And Ansible Python interpreter is version 3. Nice. And this is Debian Stretch, which is the same thing, the Python 3 as opposed to Python 2. So we'll go back and see if this machine is ready for us. So let's go to the dashboard and see we have one machine running, and that machine is give me a box. So I will say, okay, I want to connect to this box. So let's go first check the connection. How do you check the connection? The regular way is to just SSH and say yes, and it should let me in the Scaleway cloud. So I'm in, I come out of it, exit. The other way of establishing a ping is to just Ansible all -m ping, and I'll ping all my hosts. Currently, I have 2 of them. The one is DigitalOcean, which succeeded ping pong, and the other machine is late for dinner. It also succeeded ping pong. This ping pong was slightly slower. You notice it. It took a little time for a simple reason, that it is not in the US. It's away from us. It's in Paris. So it takes a little hop, 1 extra hop across the Atlantic. I don't even know exactly how the traffic is going, but I'm assuming it's going through Atlantic. And therefore, this little bit of delay, you can notice it. It is noticeable. You can also measure ping times as to how far the machine is by just pinging it. And notice the delay in these 2 pings. So we have the IP address, grab it, and say ping, and measure the millisecond time. It takes 150, 159, 159 ms. That's the ping response time on that box. Let's go see, compare with DigitalOcean. The ping is kind of faster. So copy, this is San Francisco machine. So our ping response on an average is 40 millisecond, 30 millisecond, 37, 38. And that's the average. So it's relatively different. You can see that the average ping was 31.8 versus the Paris average ping was what? 157. So that's how you can tell how far the machine is from you, from your location. But both pings succeeded. So what do I do now? If I want to configure all my machines in a place to run Docker, I want to make them my Docker host. What do? I say Ansible run the Docker play and go. So it will do these things that I have in my mind, that I have written down in a play that is in my playbook called docker.yaml, which uses a role called Ubuntu provided by this gentleman, and is going to run that role on all the hosts. And all these hosts that I have are 2, line number 7 and line number 8. 2 machines, all of them, both of them will become Docker hosts in a matter of few minutes. The first one is already done, so it is skipping for that machine. Most of the items will be skipped for the DigitalOcean machine, but for the other machine, it is going to run those things. For late for dinner, it will run the missing steps that are not done yet on that machine. So what is it saying? Wait for, there's probably no reboot. So this is not actually a failure. You can see it in a red color. It shows fatal, but it's not really a failure because it is not critical, so it is ignoring. And at the end of the run, you will find that it reports whatever it does, which I'm assuming is going to be successful. But our operating system is slightly different. As you notice, the machine called late for dinner is not Ubuntu. It is Debian stretch. The machine DigitalOcean is Ubuntu 16.04. You know that already by the choice we made for this machine was Ubuntu 16.04, whereas the other choice we made for the other machine was a different OS, Debian stretch. And so that is what is going on right now. Let's wait for it to finish. And when it finishes, we cross-check and then move on to the other exercises. That's what I'm waiting for this to happen. And the machine in Paris is not only far away from us, but is also somewhat slow in my experience in terms of using the cheapest machine in DigitalOcean compared to the cheapest machine in Scaleway. The Scaleway machine runs a little slow. I think that's how they make money, is the pricing that they have is like €3, which is ridiculously low for a month. So here's the machine I got. It gives me 2 cores, 2 GB RAM for €3. And let's compare what machine I have here from DigitalOcean. So let's go side by side. And what did DigitalOcean give me? DO, where are you hiding? There. So this is DO, and they gave me for $5. What did I get? Come on the other side, please. And I got a 512 MB memory, whereas Scaleway gave me a 2 GB memory. So it's more memory available in Scaleway compared to 512. And the performance of this 512 machine is turning out to be slightly faster, probably because the CPU is more modern compared to this. That's one reason. There may be other reasons, such as this 64-bit technology that you have. Maybe older generation, maybe their virtualization engine under the hood is slower. We don't know these things because they don't tell us. All I see is the time it takes to finish something is longer in Scaleway compared to DigitalOcean. That's what I see from my usage perspective. And here the memory is 512, the price is $5. If you compare this and convert €3 to USD, see what the pricing today is, how much. So it's $4 for the Scaleway box and $5 for this DigitalOcean box. So yeah, I don't know what to bet, but I think we are talking about the bottom of the pyramid, or rather bottom of the totem pole, or whatever. The cheapo machines. We're talking about cheapo machines. These machines are not the ones you put in production. So they're not good candidates for comparison, like A to B cloud A versus cloud B. It's not really meaningful to compare like that, because they're low-end scrap machines that nobody cares about. They're just good for testing. And so we are doing exactly that, just playing with machines. So you see that it is still doing its stuff, whereas by now it should have finished on DigitalOcean. You notice, and that's what I observe is some clouds are slower than the others. So what does that mean to you and me? When you want to run some given applications in some clouds, you have the choice of running in here versus there versus other places. Always test with your application running on that cloud A, cloud B, cloud C, and make sure that you're happy with the end user performance that you want. Don't just go by, hey, this is cheaper, only $4 a month compared to this is $5 a month expensive, and I get only 512 MB RAM versus here this guy's giving me 2 GB memory. Doesn't make any sense to me whatsoever. I don't understand this aspect of what I call pricing versus sizing of the machine. It's irrelevant to me. What I really think about is how will my user perceive the application that I run on this cloud versus that cloud. That's what I really care about. If my users are happy, then apparently my choice of cloud was good. If my users are not so happy with the performance, even though I may be paying more or paying less, or maybe choosing a bigger machine or smaller machine, apparently bigger or apparently smaller machine, it's all irrelevant. In this, you are my Docker host machine, we just have one CPU. Let's go that and check, compare, and make sure that we are actually talking sense. So I'll go compare and cross-check, and I think we have one CPU. There we go. So it's $5 per month, 512 MB RAM with one CPU. These guys are giving me 2 cores of x86 64-bit core and 2 GB of memory. Here, 512 MB RAM and one CPU. But still, this one is faster. You can see that from real life perspective right here. This guy is done and it failed apparently for something. Username is undefined, which is actually my problem. I forgot that step. I forgot that step because I should have a file here that defines the username, which I did not. I should have created that file like this. Say, copy this new file and create a file called late for dinner and save it with a username and then run the play. This username is expected to be there in a file called late for dinner. Rename the file again, .yaml. And so therefore this late for dinner.yaml was not there when I ran it, and it did not know what the username value it should take. So it basically could not find that value is undefined, so it failed. Now, if you run it again, it should just take care of it. But it's immaterial. The point that we saw is that across some variation of operating system, Debian versus Ubuntu, the same family, by the way, two different clouds. This role that we have will function basically across any Debian Ubuntu variation. You can see, starting from version 12.1204 all the way up, as indicated by this gentleman here. Where is this guy? Where is my friend? That guy. So he has called it out, and it's going to open up right now. Come on. Yeah, there we go. So he has called out that it will work on any Ubuntu starting from version 14.04, not 12, 14.04 onwards. Any Ubuntu or any Debian variation. That's what his claim is. And you can read that claim in your meta main.yaml. It says the supported platform versions are Debian Jessie, Debian Stretch, and Ubuntu Trusty, Janial, and Zesty. That's what he's testing with. So these things will work. So as long as you have these operating systems, you run the play like he's described in the README file, which is basically this block of code. Very simple. And you have your Docker host. What this basically leaves us to is to have our machine converted into a Docker host, Docker capable machine. This is just one machine. We can do this like on hundreds of machines, just like that. It'll run and do the magic for us. Once that magic is done, like it succeeded this time, it changed the late for dinner guy because it was able to find out the item called root for the user to be added to the Docker group. This point is, by the way, moot because the root user already is all capable. So it was irrelevant. Having done this segment, what I would like to do is just go back to that machine and connect to it pretty much with an SSH command like this, and make sure that we actually have Docker, not that this thing is cheating on us, but say Docker info, and you got Docker. And Docker ps-a should show you nothing, which is expected. So that's what you have in these two boxes. We now have running. We have Docker running on these two clouds on two different machines in two different underlying operating system, but the same exact version of Docker 6CE. By the way, Docker is also into two different versions these days. Docker.com, you can see that. And Docker is now available as a community edition and a enterprise edition. You can see that in their front page. The commercial version is called enterprise edition. But don't let that confuse you. The Docker CE or community edition, the product that these guys define, there are two variations of it. The community edition versus the enterprise edition. The enterprise edition is how this company makes money. We let them make money. We don't go into that direction at all. We stay here, community edition. And that product is available in the open source for free. This product, that's what we are talking about. When I say Docker, I mean this, not the enterprise edition. When I say Docker, I'm basically going to github.com. Sorry, GitHub, Docker, and that's what I'm looking at, the CE product. It is called out explicitly like this name, CE says, Docker CE. It is the Docker Community Edition. That is what we have installed on these boxes. Like here, for example, in the Scaleway Cloud, if you look at Docker info, you will find it is installed Docker CE. Where is that? CE. Okay, Docker version. There, CE. Docker 17.9.0-CE. So that's the community edition you saw installed from here, from GitHub and bunch of associated places. And we want to run this particular product, not necessarily the commercially licensed product, which is the enterprise edition. Your company might have this product in your company, I don't know. But if you have it, they're basically the same things, but The way that this company makes money is by providing your company some extra services and support for critical deployments, critical things that they might have. So you pay them money and you get extra support from the Docker company. That's how open source companies make money. And this is their business model. That's how, but we are focusing on the community edition. The products are essentially the same thing. Not from a commercial standpoint, but from a technology standpoint. They're the same exact things from a technical perspective. They're not different. Don't let anybody confuse you about that. There is all the chances in the world to let people tell you that they're different, but no, they're not. Technically, they're same. Commercially, yes, they're different. Money-wise, they're different. But that's a different topic. Now, having done this section, I would like to take a short break, and that's what James is asking for. And so we will do that. I'll start a timer, take a short break, and then jump onto a Docker exercise. That's what we are going to do right now. So here's a timer for 10 minutes, and off we go. Timer started already, and here we go. So I will now walk away and come back. Hello.
Hey, Nilesh.
Hey. Looks like you're back.
Yep.
Okay. So on this topic of what we just discussed briefly, is this across two different clouds, we saw some different behavior. I think that deserves a little bit of more examples, I think, that give you a clear idea about how performance characteristics vary cloud to cloud. Because people seem to get this illusion that a bigger box is a better box. That may not be true, as you saw in this example of this particular cloud that we just played with. What was the play was with, where was that thing? Here? No. Yeah, here. You saw this 2-core, 2 GB memory compared with the other side was, the other cloud was DigitalOcean cloud. Where did it go? I think I have too many windows open. Let me just shut them down. So close, 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 close. Okay. Yeah, I think I closed out most of them. And now I will bring back the DigitalOcean thing again in picture and put these two things side by side to, and maybe add more examples to get us a good experience about evaluating multiple clouds across the spectrum of what's available out there. So if you start a machine of a particular size, the machine might look small to you, it may perform better, which may be a strange thing to observe. Like you see this side-by-side comparison of two different items. These guys, they call it VC1S for the size type. VC1S 2 GB memory, 2-core CPU. And here is 1 CPU and a half a GB of RAM. Let's do comparisons of the same type with a third cloud and a fourth cloud, just two machines side by side again. So total of 4. And we'll run these plays to understand how quickly they perform, how quickly they respond. So here we go to the Amazon cloud. And on the other window here, we'll go to Azure cloud. And so here is, hold on, am I causing echo or something or what? Hello. Yeah, I am causing echo. Ooh, what is that?
It seems like a great place for automation would be to build some sort of suite that takes a certain workload and distributes it on different machines and benchmarks them. And
yeah, there are tools like that, by the way, that will do bench. They'll do bench just like that, like you described. That's exactly what I wanted to point out to you, but I wanted to do the other way, the example we are running in that context. The way industry runs it with standardized benchmarks for a given type of applications, they will have some kind of a bench test, and they'll run the same test load across multiple setups, sometimes comparable setups, sometimes not so comparable setups, and just try to get a sense of which setup performs better for that particular benchmark. What I'm doing is a proxy right now, how quickly the Docker install finishes on a given cloud. That's my proxy. You can use any proxy, but the best proxy is not these benchmarks. The best proxy is what the customer tells you, what your customer tells you, which is better, this cloud or that cloud. That's what is the real true test of a benchmark. Every other benchmark is just a benchmark that nobody cares about. Only thing that matters is whether the customer says, yeah, it is good. That's all it is there to think about. Nothing else is, everything else is BS in my mind. I don't care about anything else. So honestly, you should not order. You should not either. Having mentioned that, it is all about the customer. That's what I'm saying. So go to Windows, Azure, and let's see if I can log in on both these sites. And come on, log in, please. Next. And here also you log in on the Microsoft side. Okay, account, my account. And where is the login button? That's the challenge I always have with Microsoft. but I'll figure it out. First of all, let me log in this side, and then I'll go this bigger and find out where to log in. My account, portal maybe. Yeah, portal. And here I try to log in and say, please log in, and work account, and then my password and sign in. And I'll get a text message now. And there it is. And the number is 523841. Okay. 523841. And I verify, and now I am in the Azure cloud also. So what I want to do is get similar, comparable, cheapest possible machines out in both these clouds. So first one, refresh. Okay, I'll go to add a new, in the dashboard, I want to get a new resource, so new. And here I want to get a new machine. Where is my machine setup? Ubuntu server, there we go. Popular Ubuntu server. And you will notice something off the bat is that the web browser interface itself with Amazon, with Microsoft is slow. So that is something that you will notice. So here I'm saying, give me an Azure machine. I will call it my Azure machine, and get an SSD type machine with SSD, and assign a username. Here I can choose my username the way I want. That's the good thing about. I don't want to fill up from my address book. I want to type in my username. So my name is Nilesh, and I want to provide a public key. So here is my public key coming in. I will grab it from my location, and this is my public key. So I copy it carefully like that, copy, and go to my Azure cloud and paste the public key right in that window. And now I select a pay-as-you-go subscription and create a new resource group. So I'll call it Bootcamp, and set this location in US West. And now I am ready to kickstart a new machine. So I'll say OK. And this should start a new machine. I need to choose a size. So here I'm choosing a 1 CPU, 3 GB, 3.5 GB machine with 2 disks and 3200 max IOPS and 7 GB SSD and all that. So it costs me about $52 per month. Wow. Okay, these are the recommended options. So I go cheaper options, so view all, and I can probably find cheaper options. I hope I can. No. Okay. Apparently, I cannot find any cheaper options, only expensive ones. There is a cheaper option right there. It gets me. Yeah, so yeah, basically too many choices here. So I'll just pick some choice. No big deal. So I'll pick a choice, say DS1 standard, and just select this choice and say, OK, select. So I select my choice, size choice. Do I need availability set and manage disk and all that? And say, no, I just don't need nothing. Just give me a machine, please. OK, go give it to me. Click OK and go run it now. And so that's what they're doing right now, is to basically prepare groundwork to, they'll ask me more questions. Oh, you have to buy it now? Okay, I think I already did the purchase agreement. So am I getting a hourly rate? Yes, so 7 cents per hour. Okay, it is expensive for a machine, for a simple machine like I want, but who cares? Purchase. So I bought it. Then when I buy this machine, it's getting deployed. I'll do the same thing on the other cloud. I'll say go to Amazon Cloud and EC2, and in the Oregon area, I will have a new droplet created. So I'll launch a new, these guys call it an instance. So I'll say, okay, give me a Ubuntu server, like that type. And so I select it and say T2 micro is good enough for me. And I will, these connections keep on coming. And I said, do not disturb. Okay. And so I will now configure instance details. I'm going to choose my default VPC. And in there, I can select any availability zone I like. No, don't care. Get me a public IP address, please. I enable. So I can connect to it. And I will go and add some storage. 8 GB is good enough for an SSD. For this example exercise, add some tags to it, not necessary. I review my existing security groups. I have this one already. And it has my port number 22 open, so I can connect to it. So I review and launch. And then I need to make sure that my public key is provided to these guys, that I don't yet have this exact key with them. So here we go. That same mistake, not likely to repeat, I hope. So I'm going to give my public key to them in EC2 in Oregon area. And you have to give this key to every area, apparently. So you have to go to key pair section, delete the old key pair you have here, and then import the new key pair like that. And then paste your public key and say import. So now you have the public key with them. You can close this window now and then proceed forward to actually instantiate this new box. So you launch it. And then you say, I have this key pair. Now I know ID RSA, I have it. So I acknowledge. And then buy the machine. So machine gets purchased. Machine is getting ready now. You can see it here. T2 Micro getting started. It will get an IP address pretty much like that, showing up here in the public DNS public IP section. On the other hand, we'll see that our Microsoft friends, what are they doing for us? So we'll go see them. And they are busy deploying a server. And they're doing it. And so are these guys in Amazon. So, give me the IP address, please, Microsoft. They will give it to me eventually when they are ready. These guys have given me the IP address. So I will take it and go back to my virtual setup in here and put a host entry for the name Amazon so that I know these names are going to be used, so that YAML file is already there in place. The host entry I want to actually use is the first one. So I'll bring that up, and this IP address needs to change. So I'll put my correct IP address right there, and everything else is okay. The one I want to do next is this Azure Cloud, which I want to have an IP address for here, which I will fill up. The Ansible user I have chosen in Azure is Nilesh. And as a consequence, I need to create a new file like this Late for Dinner, or maybe like this DigitalOcean, or more like Amazon, except the username is not Ubuntu, but Nilesh. So I will create a new file that hold my variables. I'll call this azure.cloudgenie.us.yaml. And there I will, in that new file, I created a folder by accident. So delete. It's a folder. I don't want a folder, I want a file. So new file, azure.cloudgenie.us.yaml. And in that file, I want to save it, but not use the name Ubuntu, but instead use the name Nilesh. And save again, close it. This file has to have a name extension by rename it to be YAML file. .yaml. And now I have a YAML file for Amazon, a YAML file. These files are really strictly not necessary unless you're using custom usernames like Ubuntu, for example, or Nilesh as another example. That's the reason why you need to have these files to indicate to Ansible that I have a different username. That's the only reason why you need them. So I'm closing them out. That's what I have called out here. And in the variable reference, so that I can assign that user as a Docker host, or sorry, Docker group member. This Google Cloud, we are not taking that example, so I'll put that on the top. We have an Amazon machine, an Azure machine coming up. DO and Late for Dinner are ready already. These guys, the last two, line number 6 and 7, they're running already with Docker. The line number 4 and 5, we are waiting for the machines to get started. I think the Amazon machine should be ready by now, so I should connect to this IP address already. And I will attempt that right here, SSH and Ubuntu at IP address, and say yes, and it connects. So that's good. Do I have Docker there? Not yet. Nothing, not installed. So I exit, and fine. I will now see if I can get the other IP address from the other cloud here. So in the Amazon, sorry, this is which cloud is this? Google, no, Microsoft Cloud. Do I have an IP address from you yet? Apparently so, right there. So that's the IP address. Let's copy it and go back here and say, can I connect to you, please? And it connected. Nice. Now what I do is I make sure that I connect using the name Nilesh that I chose, because that's what I chose. So I need to go back to my cloud setup here and put the Azure IP address like that and save it. Now, I would like to remind everybody that these names are, again, whatever you want. They don't need to be Amazon or Azure or DigitalOcean or late for dinner. You can call them exactly late for dinner, whatever. It doesn't matter. What matters is the IP address. That's what matters. These names are convenience for us to remember that, hey, that IP address actually is the Amazon machine. There is no other reason why you need to have these names, just for convenience. And we somehow know that late for dinner is Scaleway Cloud, somehow. Having understood these pieces, I will close this window out by Control W. And now, in my command line, I will exit from this Azure cloud, which I am connected, exit, and I will now Ansible, all of them, please ping. So it goes and pings all the clouds, 4 of them. And you see the 4th one is slow. You find the fastest one was Amazon. It quickly responded. Azure was the next, and then DigitalOcean, and then late for dinner. Do it again. These are just ping responses, right? Don't read too much into it. Don't read too much into it. The way you should actually assess performance is from a real customer application, not through a benchmark, not through any of these ping tests. They're all of them are irrelevant. Only thing that matters is the customer saying, yes, this is good versus that. That's it. Having understood that piece, I want to run the playbook. And Ansible playbook, play my Docker play. And here it goes. So it plays. On this time, 4 clouds. These 4. 2 of them are already done. So they will be skipped. The other 2 will be set up with Docker in the next 6 to 7 minutes. You should see that finishing up. I think Azure Cloud is spending a whole lot of money. And I think the machine we have from Azure is a little bit expensive one. It has given us 1 CPU and 3.5 GB of memory for an expensive price, relatively speaking, compared to these guys, which are T2 Micro. And so T2 Micro price is what? T2 Micro price is cheapo, right there, 1.3 cents. Whereas the simplest, cheapest machine you could get from Azure was, what was it called? It was called DS1V2. Okay, so DS1V2, what does it mean? DS1V2 pricing. Let's go understand that pricing. And here is the DS1V2 pricing is, wow, they're giving me a discount apparently. So I got it for 7 cents and the price listed is 12 cents. That's a high, and the high pricing for no reason. Yeah. And these are the cheapest machines you can apparently get on, at least I did not do full research, but looks like that's the cheapest you can get on Amazon, on Azure Cloud. On Amazon Cloud was T2 Micro is 1.3 cents per hour. Here the pricing per hour is 12.3 cents, which is kind of 10 times more expensive.
Is there like, they provide support or something? Is that why they charge more?
I don't know. I don't think I get any support from anybody. I don't get any support from anywhere whatsoever, unless, the only way I receive support is open source people helping each other out. That's my support channel. So yes, I get a ton of support from people on GitHub and Slack chat, and I participate. I help them out. They help me out. It happens. But commercial support, I don't take it. I don't want it. I don't need it. So yeah, I don't think I have a support model. but apparently they gave me a discount on this 12 cents. They gave me for 7 cents, it seems, which is fine and dandy, but I don't care. But yeah, the thing is running right now. Let's go see what's doing. It's doing it, and it is comfortably skipping the Azure. Skipping the things that need to be skipped. So it is doing those installs right now, and you should see them succeeding at some point. And if you run one cloud at a time, you can time it, and you can measure how much time it took. So one cloud versus the other. This is one way to measure. There are many ways, many ways. I think we're about to finish our exercise in this particular exercise, because we are at the last stage, and it just finished. And you can see that it skipped DigitalOcean and Scaleway. It did the Amazon exercise and the Azure exercise. Now let us go and find out. Can I connect to my Azure machine? Yes, I can. Do I have Docker there? And can I, by the way, run Docker as Nilesh? That's the thing, right? Run Docker as Nilesh. Can I run Docker as Nilesh? Yes, I can. Without sudo. That's good. Now let's go to the other cloud, which is the Amazon cloud here. And there, can I run Docker as Ubuntu? Yes, I can. And you saw that. And basically, I don't need to become root. I don't need to give sudo. I am a member of the Docker group by definition, because of the playbook required that. In this example, you see that. In this Nilesh specific example, you see that. This user gets added to the Docker group automatically in this play, as you see here, line number 9. And that is our attempt to run Docker on 4 different clouds on 4 different machines, with one variation in Scaleway cloud. We chose a different OS, Debian. Not too different, somewhat similar. Same. Debian is the parent of Ubuntu. Ubuntu is derived from Debian. So Ubuntu is baby. This guy is the parent. I should say child, not baby. Now, at this stage, I want to change our exercise itself. And first of all, I want to kill all these boxes that I created. So I'll go there and do that very, very easily. I go here and say, delete my Azure machine, and it should delete that. Great. Now here I say, T2 micro, you also go and please die. So instance state and terminate. So yes, please, you are dying. You're dying there, right there. In my Scaleway cloud, I see that my dashboard shows me a server running. I want to make that server turn off and terminate and power off. And that machine dies. And now in DigitalOcean, which is the 4th cloud, we'll go and destroy that machine right there, log in. And we see the droplets come up. And that droplet I want to destroy. And it dies like that. So 4 machines dead. Now our ping, of course, will not work anywhere else. So this ping exercise will fail 4 times because all these machines are dead. And that's what I want to make sure, that they're dead. And then I will change our exercise. What I would like to do now is bring back that old Docker exercise we attempted like one time before. And there are more things in that same exercise that we need to explore. That's what I will be doing in, how much time we have? Like 20 minutes. Okay. So that's a fairly elaborate exercise, by the way. So let me actually take a portion of that exercise and we do the remainder later. So what I'm doing is bringing that exercise up again. You have done a part of it. That exercise was called Docker files on GitHub. I will bring a link for you and put that in Slack chat just now. This exercise, we've done it already. And I will bring that one in Slack chat and paste a link. That's what I'm doing right now. So this exercise requires us to bring those examples in a Git clone. So we'll clone that thing locally in our workstation, come out of that folder, and in here, in our PWDs, the home user folder, in there, I would like to Git clone that exercise one more time. We've done it before. We did it partly did not complete the entire set of exercises, I will run that exercise to give you a different use case, a different use case of multiple clouds, or rather, not multiple clouds, multiple services on one box, the opposite of what we just did right now. So we had the same application, multiple clouds. We would like to have multiple applications on the same box, the other opposite. That's what I would like to show you now in this example. So we have the Docker files folder, and I will open that in Atom Edit and describe the concept before we move forward. So here you have done this exercise in a 3-tier example before. You have run that part of the exercise, which had a WordPress image running a WordPress container, and a MySQL image running a DB container, and a data image that you create by building a new image and then using that image to run a data container. So these 3 containers, data, DB, WP, you've done it already in a previous attempt to running this exercise. What I want to do now is a different exercise, which is in the other files. And that's what I want to actually pull up. So if you see this Docker compose YAML file, you find that it is empty. And that is exactly how we would like it to be. Now in that empty file, what I would like to do is copy YAML snippets from the example files and paste it here, one item by one at a time. So here is our main set of examples. And what I'm doing is looking at a segment at a time. And so here is a segment. And below that is another segment. And below that is another segment. So these YAML segments are essentially independent containers that will run based on the selected image provided. So here is a C1 container running the image, and like that. So every example that you will see here is structured pretty much similarly, that there is an image reference that will run and become a container by that name. So there are lots of examples here, by the way. So what I want to show you is, first of all, the understanding of what this thing will do and why and where it is useful. So that idea is on a white sheet of paper, looks like this. What I'm trying to do is I want to run a bunch of services in multiple containers. And when I say services, I actually mean applications of some sorts. Different applications, completely different and independent from each other in separate, isolated containers. I'll call them C1, C2, C3, or maybe give it a better name for them so that you will really comprehend. I will give it a name called CNN.com. I will give this guy a name of foxnews.com or fox.com. So just naming them, right? Random names assigning to different services, different websites. And I want to run these services to give you an idea about what a Fox News site will be looking like. We'll be running the C4 application in this container. The CNN.com website will be running in a C1 container. And we'll run the CNN application. And I want to create these 1, 2, 3, 4, and many such containers all in one box. Can I do that? It's not the question of should I do that right now, but can I do that? That's the question. The answer is yes. The answer is always yes. It is always possible to accomplish something, right? So, but can I do that? Yes. Should I do that? Maybe. Depends on use case. So the other flip use case of the same idea is that you want to, for a large application, say CNN.com, you might want to have multiple boxes running the same application so that your millions and millions of users who are visiting this website will be serviced comfortably, and the load will be shared across by a large number of boxes like that. And they will all be able to collaboratively respond to user queries, and show what the user expects to see millions of users hitting CNN.com. Could be Fox News, doesn't matter. But that's the flip scenario, which is this is machine number 1, machine number 2, machine number 3, machine number 4, like that. Multiple boxes, same application. This usage model is called load balancing. Load balancing. LB. The classic usage that is enabled, the software that is enabling this scenario, a classical piece of that software is called HA proxy. You may have heard me say that. HA proxy is the application, open source, that enables load balancer. That's what you put right here. That enables you to distribute this user load of millions of users hitting across multiple boxes. So this HA proxy is basically a forward proxy for word proxy. In this usage, the way I'm describing, this usage model is considered forward proxy. The opposite of this is considered a reverse proxy. In that other usage scenario of the reverse proxy, you can use HA proxy software, or you can use Nginx software also as a proxy. And that is what I will be using, the Nginx software as a reverse proxy, by the way, in this example. And now what does reverse proxy do? Essentially what it does, if you have a box running CNN and also Fox News, you put the reverse proxy here. And this user, when they come and ask for CNN, they all hit the same IP address. And this other user, he or she comes and asks for Fox News, they also hit the same IP address. Same IP. It's the IP address for this reverse proxy. And inside, behind the reverse proxy will then decipher which application should service this request and which application should service this request, and will appropriately transfer traffic to that appropriate portion which runs CNN. So this person will receive response coming from this application through the reverse proxy and be sent there. And this person asking for Fox News will receive the application response coming from Fox application through the reverse proxy and go to that guy. That's the idea behind a reverse proxy. We will be using the Nginx application in its reverse proxy function, as opposed to up until now we have used Nginx as a web server. So Nginx can be used in multiple ways. This example uses Nginx as a reverse proxy way. What we want to do is, in that example here, there are a bunch of services. Like here is the reverse proxy. And below that, one application, and another application, and another application, and another application. So there's a whole list of applications and a list of services running, collectively forming together a set of things that should be shown to the end user. So the end users are here outside, and they are going to ask for C1. This guy wants to ask for C2. This guy wants to ask for C3. They all hit the same reverse proxy. And behind the reverse proxy knows that, I have this container running here called C1, and this container running here called C2, and this one running C3. And this container requires another container called database for C2. And this container requires another container called database for C1. And this container has a database inside here. And maybe this container has another thing that is a Redis database to expedite the database performance. And that connectivity, we will talk more about how we wire them together. But a large complex collection of various elements of services put together to construct a variety of services such as C1, C2, C3 is what reverse proxy will actually use and connect these three people with appropriate responses to the request that they ask for. So a person receiving, a reverse proxy receiving a request from this guy asking for C3 will divert that traffic according to this container and get the response back and send it to this guy. And that's what the function of a reverse proxy is. Was there a question somewhere? I heard something or no?
Yeah, Nilesh, I was just wondering, so those three websites, they all have their own domain name, and they'd have all CNAME records pointing to that one IP address. Is that right?
Yes.
Okay.
Yes. You have to have that.
And then it's in the header. It must be in the header that the actual site they're trying to visit gets picked up.
I'll show you the header. I'll show you the request, show you the response, and you can see it. You can read it. It's trivial. It's intuitive, but the mechanics I will walk you through. It is intuitive, actually. If you think about it, it is simple. You have this person asking for, say, cnn.com. Then you find out where the service is running in your cloud, and you just figure out that, hey, it's running here. The C1 container runs cnn.com. I see. I know. I need to know that, by the way. So this reverse proxy needs to know that the cnn.com domain service is running by the C1 container. I need to know that. So I know that it is running here. So I can just take the traffic and send it to you. And you can respond back, and I'm happy, and everybody's happy right now. So that's how you put a reverse proxy in front to deal with a collection of services that you can put behind the scenes and mix and match and manage and wire it up exactly how you want. But you don't want people outside to be exposed to what you are hiding behind the scenes. And that's the scenario that I'm describing. This example uses Nginx reverse proxy. There are many other beautiful reverse proxies available. One of the ones that I recently started using, and I like it, and is in production right now, is called really good. And it is in production right here in our site. This site is behind a reverse proxy called, what is it called? Traffic. Yeah. So we'll talk about traffic later, not right now. Let's talk about this example that we have in mind, which is not this yet. This. It's another good one. The actual reverse proxy is created by this person. And so he has created this Nginx proxy, which is basically a Docker container that generates proxy configuration using Docker Gen. That is a popular repository with like 1292 forks. And it is what I am going to use as the first segment right there. Here. This is the first container I want to run in a machine. I will run it right here on this virtual machine right now because it's easy. We can run it anywhere. You can take this repository anywhere and run it in any cloud. Doesn't matter. But I'll run it right here. So what I want to do is take this segment and copy it from here and put it in my Docker Compose YAML right there, like that, and say, paste it. So now I have a new reference to Nginx reverse proxy by JWilder, which uses the JWilder Nginx proxy image. And it will run a container called Nginx proxy. Open the port number 80 inside the container and map it to port number 80. Sorry, this is the port number 80 outside in the machine, mapping it to port number 80 inside the container. This is the volume mapping. I have docker.sock on the physical box, mapping to TMP docker.sock inside the container in read-only format. The image will be JWilder Nginx proxy, which is available on Docker Hub and is open source, and you saw the Git repository right there. When the container sometimes, occasionally, if it fails, you restart it. That's our goal. So I will save this segment, Docker Compose YAML segment snippet, close it out, back here, and I will say Docker Compose up and -d option to go in the background. So it goes in the background and pulls that image that you're looking for, Nginx reverse proxy latest, and it will stand up a container for me that runs Nginx proxy. And something happened. The thing that happened is that our address is allocated already. Something is probably running up in there, probably my Nginx exercise or some other Apache exercise, something is running. So let's go find out who's running. I need to kill them. Yeah, Nginx is apparently running. So what I will do is, and this is running directly on the local machine. So I need to shut it down and get rid of it before I can run the exercise. I need to make room for the port number 80 to become available on the physical machine is occupied. That's why it started, ran into this error, starting userland proxy, listening to port number 80 on the physical box, failed because this guy is occupying the territory. So you want to get rid of this guy. Sudo apt remove nginx and password and yes, and then sudo apt get auto remove and remove all the dependencies. Did I type something wrong or what? Yeah, it's doing it. So now the configuration is all gone. My port is free and I can run my Docker Compose up and it is running. So I can see that there is a Docker process running with port number 80 on the physical machine mapped to port number 80 on the container inside. The container is running the jbuilder nginx proxy and it has a container ID available. Now, if I go to the local machine and try to open up this website called localhost on port number 80, I will see nothing, even though I'm running something. I say go to localhost and it says, no, I don't know what you have. I don't know what to do with you. I know I'm running Nginx reverse proxy, but I don't know what to do with you. This localhost, I don't understand it. So this is actually your Nginx reverse proxy responding to you saying, I don't know what to deal with, how to deal with you. You are localhost, you want what? I don't know. Don't recognize this DNS name. So now what do? I need to actually run something and tell Nginx reverse proxy, hey, when somebody asks for something like cnn.com, give them this. That's what I want to show, right? So I will go here in this example and say, you know what? If somebody comes and asks for, say, cnn.com, fine. You know what? You give it to them this thing. Just show it to them this thing. You know what this thing is. It's a two-tone WordPress ready-made image, not good for production. But I'm just going to give it to them and call it cnn.com. And the virtual host I'm going to define is cnn.com. So if somebody says cnn.com, show them this two-tone WordPress. You know what this thing is. You have seen it before. So I'm going to save it, close it, back here, and say Docker Compose up again. And so it is going to actually, let's see if I can Docker ps-a, and there is this Nginx proxy getting pulled, and it is up, and it is serving on port number 80. But again, this is not a machine port. This is container port. The machine port looks like 0000:80. That's the physical machine port mapping to a port inside. And this guy will then talk to the port number 80 on this container, provided somebody is asking for cnn.com by name. So if you go here and say cnn.com, you see what? You see cnn.com because that's the DNS name, right? And so you see CNN there. So what's the point I'm trying to say? The point is like this. You have to simulate DNS and actually indicate that your host file, which is this file, should actually fake that my CNN is this box. So I will fake it like this. This is how you can, run it in a simulated environment. So I'm going to edit my local host and say, you are also going, let me show it to you here. You are also going to be known as cnn.com. I just cheated and said, my host file says, this machine is cnn.com. Are you kidding? Yes, I am, but I know that I'm kidding. So back in my browser, if I now visit cnn.com, what do I see? After I refresh my cookies, hold on, let me clean the cookies. So cookie cleanup exercise, preferences, and search, privacy, recent history, all of it. Come on, everything should go clear. And then close the browser and open cnn.com again. And I go cnn.com, boom. And what do I see? I see WordPress. Do you know why I see WordPress? This is the WordPress that I just set up using Tutum Pro WordPress, right? That thing here, these guys. You see why I'm seeing WordPress? Because I am cheating. I'm telling my reverse proxy that this machine is CNN. And so reverse proxy says, are you? And it says the host file and says, yeah, you seem to be looking at the local machine. So I will serve you cnn.com. I know where CNN is. CNN is running in line number 21. And that's what just happened. You get what I'm talking about? You understand what's going on? Or do you not? If you do not understand in the local host context, I will move this setup to a different real machine out in the cloud to get you a real idea or understanding. I think that's what I will do next. If this can be cryptic to understand what I just described. If you did not understand, I will clarify and simplify this understanding. But this was a hack that I just did to help you quickly understand what's going on. I hope you get it, but I doubt that you actually understood what happened. So if that's the case, that's okay. I just want to know that if you understand what I just did already, please tell me so I can cut on some time. If you did not really get, I will show you another way, a more logical explanation of what I just did in this example next time. So what I did was this entry was a hack that I put in place to make the DNS system believe that my container C1 is actually cnn.com. So it's only in this box that you will see that this website, cnn.com, looks like, this WordPress site. I am the cnn.com. And here I am pretending to be CNN. It is not CNN, I know it, you know it, but only in my box right now it shows like it is CNN. And here, I am the CNN.com, the real one. Is that true? No.
Yeah, because Etsy host gets resolved first, right?
Yeah. So that's what I just did to illustrate a point. And you can construct out in any kind of scenarios internally in your company or maybe in a public cloud setup, but you need to control DNS. So this is my way of locally managing my DNS. So it's a quick and dirty way of doing it. This is not how you would do it in real life. So the way you do it in real life for a given application that you want to run for a company, for production, you have to do certain things in the DNS, which I will do next time. On the same exercise, we'll continue. There are lots of things to discuss here to understand how do we manage reverse proxy to control a variety of services in the backside that are hiding behind the proxy. And that's what I think I will do. I'll let you digest this idea, but this is truly a hack, like hardcore hack, no doubt about it. But it's a quick and dirty way to get the point across in 20 minutes that I had. So that's what I did. I will now pause recording.
Hey, Nilesh.
Yes.
If you use the totem image, like if you just wanted to put a path to an image you had, you could do that, and it would it would put that on the web. I mean, it would paint that image. Get what I mean?
You mean a path to what again?
Like a JPEG image on your, I don't know where it'd be, on your local host.
I think I understand the confusion.
Yeah.
This line number 22 image is not a picture.
Mhm.
It's not a JPEG. It is a Docker image. It is the file system under the hood of the container running 21 CNN.com. It is the file system image, the layered file system that Docker is running on.
Okay.
That image. It's not a JPEG.
Okay.
Okay. I think it deserves explanation, no doubt about it. I will clarify. I think that, yeah, makes sense. I get the point. I basically budgeted for my time that I have, and I cut down steps to get to a quick
Sure. Yeah,
point.
yeah.
That's what
I get it. I get that.
Yeah. So I'll clarify this further. My goal was to get to a result of some kind of tangible result that I can show something. So here, I showed.
Yeah.
And that was not possible if I just extended it. It will go on. It's a fairly detailed exercise if you want to do it in a clear manner to understand and make sure everybody understands. So that's what I did. I will stop recording, and I will see you guys again on Friday at and by the way, Brian is back. Brian was required to go back home, and he's back here. I think I suggest that we get together again to say hi to Brian as well. And so I'm proposing another get together basically. So you pick a time, date, and see if you can join. I'm going to suggest some dates, like 26, for example, October 26. That's a suggestion. We can go to a different place this time or same place. I don't care. 26th at 6 p.m. is my suggestion. If you can make it, say yes in Slack chat. Brian is back from his required family attendance. He wanted to go home for a purpose. So he's back. And I'm still recording. Okay, hold on. Let me shut down the recording right now.